Morning, everybody. Just checking if people online can see the screen and can hear me. Hello? Anybody online can hear me? All right, let me just change a couple of settings here because can anybody confirm that they can hear me online? Just want somebody to confirm. Let's see who's there. Dean Carr, can you hear me? Can you see the screen? I can't do anything until somebody confirm that they can hear me. Somebody said yes? All right.
Yes, sir.
I can hear you.
All right, cool. All right, so today's session really is your day. Tomorrow is exam. So this is your day to bring forth what you want me to explain today. In particular, I mean, it's about doing exam questions. So I think we can take the format of you bringing questions that you have encountered that you want explanation for. We would have completed basically about 28 past papers, most recent ones, and all the videos are there online for those sessions. But still, sometimes, you know, you just have a deep feeling of uncertainty about something. And so maybe this is now the last opportunity today for us to just get a chance to explain, at least try and explain something again. So we can have some clarity going into tomorrow. At the end of the day, we don't know what's coming out the exam paper. So what you want is that you wouldn't want to know that you go in the exam room, there is something that you're not certain about, and you go in the exam room and buck up on it. You understand me? So if you know that you have that issue with something that you're just not so sure about, want some more clarity on it, those are the things that we want to address today. We try to do this thing in about 2 parts. So I'll work for maybe about 2.5 hours or so. We can take a short break and then we'll come back and work for another 2.5 hours or so. All right, the aim is to finish at about 4 p.m., which is 5 hours from now. If we finish before that and nobody have any questions before that, then you know we can just call it that and you go home and sleep and have a good time in the exam room tomorrow. All right, you don't want to be studying too late today, especially tonight, because you want to be rested for the exam tomorrow. So let's do this now, get out the way, and so on. So who's gonna go first? Which paper we're on? So basically passbook questions down to 2015. All right, that's the Morris hands up. And people online, they can come in as well. So what I'll do, I'll take one from the classroom and then I'll take one online. All right, I'll kind of alternate it that way. Huh? 14B. But 14B is 2014. I remember I said we really don't want to go beyond 2015. Well, let me see which question I'm talking about though. Which 14B I said? So 14B is actually 2014. Let me see which question that is. And the reason we say we don't want to go beyond 2015 is that I want to be able to do the solution on the paper itself. Which question? See what I'm talking about? This is the nature of those papers. Not the one that you write on. This is back then when CXC would give you a booklet for you to write the solutions in. What number? 4? Question 4. That's this one. Map scale. All right, let's do it. Let's do it. I mean, there's some space there to write stuff. So, all right, let's do this one. So, map and scale. I think it's the first one anybody been asking to be done in recent times. All right. So, I want to split the screen then and bring up a space to work on, a white space. All right, so let's do it here. No, not that one. Oh, come on, Mr. Shaw. Not that one. All right. So like I have to open another one. Open another one. Now, just give me a second. Let's open another one. Let's open. All right, here we go. Here we go. All right, so let us try to keep it from 2015, right? All right, so this question is a map and scale question. And remember, you do map and scale question just as though you do ratio questions. All right, so let's talk about some of the key things here. So this question gives us, it says the diagram below shows a map of an island drawn on grid 1 centimeter squares. It says the map in the other scale of 1 to 50,000. So this 1 to 50,000 really means that 1 centimeter on the map is equivalent to 50,000, the same unit, centimeters on the land. That's what it really means. That's what the scale means. 1 centimeter on the map is 50,000 centimeters on the land. But you have to remember that if you're on a map, you're on a piece of paper, you're going to be measuring in centimeters. You're not going to be measuring in meters, because meter will be longer than a sheet of paper, right? You're not going to be measuring in kilometers. If you measure, if you're doing the map of somewhere that is, for example, in your schoolyard, then more than likely you're going to be measuring, you're going to be working in meters, because you're not going to go to the extent of kilometers for in your schoolyard, right? Because kilometer, if you think of the national stadium or a running track, right? 1,000 meters is a kilometer. That's 2.5 laps around the track, like a kilometer. Because 1 lap is 400 meters, 2 laps is 800, and then another half lap. That makes 1,000. You have to go on the stadium track twice and 2.5 times, right? If you think of the 100-meter length of the track, right? From the top of the state, for the start of the 100 meters to the end of the 100, that's 100 meters. So if you're doing a scale of this national stadium, inside the stadium, more than likely you'll be working in meters. But still on a paper, it'll be 1 centimeters, and then on the land, you'll be working in meters. If you're doing the scale of a city, like our country, then you're going to be working in kilometers, because you're going for larger unit of measurement in terms of distance. So you'll be working in kilometers. So then they might say, you're working in kilometers, but still on the map, you're working in centimeters, and you have to convert that to kilometers. So we don't know what this is yet, but when you read the question, you will see whether they want it to work in meters or in kilometers. All right? All right, so here now, this is the map. It says, copy and complete each of the following sentences. 1 centimeter on the map represents how many centimeters on the island? This amount, 50,000. Because the scale is 1 to 50,000. So 1 centimeter on the map is 50,000 centimeters on the island. Then what you can do, you can take this 50,000 centimeters and carry it down to meters or carry it down to kilometers, depending on what they want the question to be about. The question is going to be about meters or kilometers, right? But this one, we're answering this one, it is same 50,000 centimeters. So we're going to put 50,000 right here. Centimeters. All right. Then it says an area of 1 centimeter square on the map represents what on the island? So it's simple. When you have the scale given, the scale that is presented to you like this, that is a scale for distance. This is a scale for distance. And they will always present a scale for distance. It's quite simple. Once you're going into area, I want to convert from the distance scale to the area scale. It's quite simple. You square the distance scale to get the area scale. So since this is a distance scale and I want the area scale, I have to square it, square the values to get the scale for area. So I square this side, that is 1 centimeter squared, equals, then I have to square this side as well. And that will be 50,000 squared centimeters squared. Now, more than likely, you're not going to be working with centimeters squared on the island. You're going to either be working in meters or kilometers. So instead of doing it, but the question asked us for centimeters squared. So we'd have to give them that right here. So, right? We'd have to give them that over here. We'd have to put right here. That is this 50,000 squared. 50,000 squared. If you want to write out the actual value. I think that's a mistake, though. I don't think they meant to put centimeter squared here. I really think they meant to put either meter squared or kilometer squared. But you have to just answer what is on the paper. So you square the distance scale to get the area scale. All right. So this is going to be 50,000 squared centimeter squared. Because as I said, this is the area scale. This is the distance scale. You square it to get the area scale. Simple as that. All right. Then down here now, it is telling us that given that 1 kilometer is 100,000 centimeters, they want us to find 1 centimeter on the map represents how much kilometer on the island. That's what they're asking us now. So here now, they're getting into now the actual unit of measure that they'll be used for the island. All right. So let us see now. Now this one, they give you this ratio, but other questions, they won't. So I'm going to do the question in a generic way to see what you would do if you're working in meters and what you would do if you're working in kilometers, just in case. We don't know what's coming in the exam paper, right? And they don't have to give you this conversion ratio in the exam paper as well. We have seen other questions, map and scale, where they don't tell you this conversion rate. All right, that conversion relationship. All right, so let's look at it another way now. All right, so they give us 1 centimeter to 50,000 centimeters. That's what we are starting with. This is the map. And this is the land, meaning the island. I'm going to convert the 50,000 centimeters to kilometers first. To meters first, sorry, to meters first. I know that 100 centimeter make a meter. Centi, just like century in cricket means 100 runs. Centipede as an insect means an insect with 100 legs. Centi, 100 parts. So 100 centimeters make a meter. Centi is 100 parts. You can't forget it. So 100 centimeters make a meter. So if I want to get this in meters, I can divide it by 100. So it means that 1 centimeter on the map is going to be, divide this by 100 to get it in meters. It's going to be 5. Okay, cut off these 2. So it's like this here is 100 centimeters right there, and it becomes a meter. So this 0 centimeters, like 100 meters, it becomes a meter. So it means that 1 centimeter on the map is 500 meters on the island. So if you're working in meters, guys, then you'll be working with this ratio. The question was in meters, then you'll be working with this ratio for distance. And if you want area, then you would square this. So I'm just put it under here if you're working with area. So this is for distance. And for area, we would have to square this to get the ratio for area, which we will square this side. We would get 1 centimeter squared to 500 squared meter squared. And you can work out what the 500 squared is. It's 2,500. So you could work it out. And this is the scale now for area. If you're working in meters, this will be the scale for area. You could work this out and get that value. Then now, starting back from this. All right, so let's say we didn't want this one. We didn't want this one, right? I was putting it there for information. So I'm going to put it in a box. If you were working in area, I'm trying to use this one question to cover all the possible things you might have to do in map and scale. Now, map and scale question. From this distance scale now that is in meters, let's say I want it in kilometers instead. What it is that 1,000 meters is 1 kilometer. Kilo usually means 1,000 parts. Kilogram is 1,000 grams. Kilometer is 1,000 meters. Kilo, 1,000. So to get this in kilometers, we'd have to divide by 1,000. Because 1,000 meters make a kilometer. So if we want to write this scale in kilometers instead, we change this part to kilometers. We divide it by 1,000. And so 1 centimeter would be, you divide this by 1,000, you will get 0.5 kilometer. This will be the scale also for distance if you're working in kilometers. This is for distance if you're working in kilometers. This one. So we have gone from the 50,000 centimeters. We divide it by 100 and we get it in meters. And then we divide the meters by 1,000 to get it in kilometers. Follow that process. So remember, from centimeters, because the map will always be in centimeters first. So this, whatever they give you as a scale for the map, it's going to be in centimeters first. You divide the centimeter side on the land side, and you want to see what this is now saying, you know, is that 1 centimeter on the map is half a kilometer on the island, you know. That's what this means now, you know. 1 centimeter on the map is really half a centimeter on the land, half a kilometer on the land. And right here, this line is really saying that 1 centimeter on the map is actually 500 meters on the island, if you're working in meters. You get me? That's what the scale is saying. And then if you want it, again, if you have this distance scale, and the question is going to ask you something about the area of the island and the area of some part of the island in kilometers squared, then you have to square this scale again. If I square both sides again, then I'm going to get that 1 centimeter square. Come on, we square the one to get 1 still, you know. And you square this. It's going to give you 0.5 squared kilometers squared. This will be the scale for area. If you want to work out anything in area, this is the scale that you would use. This figure would just be 0.25. That figure. But I'm showing you that you square the values. I've also squared the 1 here. But 1 squared is just 1 still. All right? So if you're working out area on the map, this is the scale. If you're working out area in kilometers squared, this is the scale right here. If you're working out area in meters squared, this is the one in the box right here. So I'm put the second one in the box. All right? I'm just taking the opportunity, guys, to explain this out so that any question I get of this form, you can do it. So based on the information, guys, we're going to put, they're looking for looking for what 1 centimeter on the map represents in kilometers. It is a kilometer scale that we have right here. So the answer for here is right in this line. This one. So it's 0.5 kilometers. So 1 centimeter on the map is 0.5 kilometers on the land, on the island. So the answer for right here is 0.5. All right, so let's put that, 0.5 kilometers. But the kilometers is there. But understand that so far? But understand that so far? You could have also gotten a 0.5 based on this conversion that they gave you by just dividing this now by this 100,000. See that? You don't get the 0.5 just to see it because of that conversion. But I'm just showing you a way in case I don't give you this conversion. And sometimes you get the question to work in meters. Sometimes you get the question to work in kilometers. I'm showing you how you go from one to the next, just in case. And some questions ask you for measurement in meters and measurements in kilometers. I've seen that. But they're asking for measurements in both. Calculation in both units. All right. So that's the first part of the question. All right. Don't need to know. The next part now says, L and M are 2 tracking stations. It says state in centimeters. That's on the map. No. State in centimeters the distance between L and M on the map. So just want to see what the distance is between L and M on the map. Now remember, the map is on a grid of 1 centimeter squares, right? So every little square you see on the map is 1 centimeter. That. So let's see to count how many squares are there between the points L and M. Let's look at it. L and M. See it here? See L here, so let's put this in red. L and M is here. How many squares between them? 1, 2, 3, 4, 5, 6, 7, 8. That's 8 centimeters on that map right now. So on the map, LM is 8 centimeters. Simple. Just count it off. 8 centimeters. Just count it off. So the answer for right here is 8 centimeters. So I'm going to put the 8 centimeters right here on the map. Watch this now. Calculate the actual distance, and I want it in kilometers, of the same LM on the island. So look how we're going to use the scale and do it now. So we have the distance scale. Let's do it over here. We have the scale for distance. We just work it out. We have the scale for distance over here. We have the scale for distance over here, which is that the map to the land, we said is 1 centimeter on the map, is 0.5 kilometers on the island. We're working in kilometers. You want to know what 8 centimeters on the map is? Do it like a ratio question. All the ratio questions, you multiply a ratio or divide a ratio by values to get the information that you want. We want the map side to become 8. So all I need to do is multiply this ratio by 8. Multiply it by the value 8 because I want the map side to become 8 centimeters. And you also multiply this side by 8. Simple as that. So what it means is that when this is multiplied by 8, it will become 8 centimeters on the map. I multiply this by 8 as well, and I get 4. So I'm going to get 4 kilometers. So it means that LM, which is 8 centimeters on the map, is actually 4 kilometers on the island. So the answer for this is 4 kilometers. But understand that? You could also count it off if you want to know. So watch this now. Remember that based on this scale, every centimeter is half a kilometer, don't it? So we can basically say then, from this, you can reason and say, okay, 2 centimeters is really 1 kilometer, don't it? That's all? So every 2 centimeters is 1 kilometer. So you can literally count it off still. Every 2 centimeters between this and this is a kilometer. So see here, so 1 kilometer there. That's 1 kilometer. That's 2 centimeters, 1 kilometer. See another kilometer there, that's a second one. See another one there, that's a third kilometer. See there, 4 kilometers. Because we have now decided that every 2 centimeters is a kilometer. And there are 4 kilometers between L and M. Everything must be in sync, you know. What you get by calculation, what happens on your diagram, must be consistent. It must be in sync. You can't be getting one thing with the calculation and your diagram showing you something else. Because a student might decide to work it out with his diagram, another student might decide to work it out using calculation. Never one way to do it. Everything must be consistent and in sync. All right. So you see still that you could have gotten it there 4 kilometers. All right. That's the distance LM on the map. All right. Let's continue down here. The next part now gets getting into area. See? The area shaded. So once you go into area, then you need the area scale. Once you get into area, you're going to need to use your scale for area. I'm doing it the easy way. It says the shaded area on the map. Shaded area on the map is a reserve, is a forest reserve. It says by counting squares, estimate. Mean that you don't have to be equal. You don't have to be accurate. But the answer is going to be a little bit different. You have to get the same answer. You're estimating. Whatever estimate you get, you work with it. You say by counting squares. I'm going to show you a little myth now. All right? By counting squares, estimate in centimeter squares. So I want to work out the area on the map now. The area of the forest reserve as shown on the map. By counting squares. Now look here now. Some people believe that when they say counting squares, you literally have to go and count these individually, like 1 square, 2 squares, 3 squared, 4 squares, 5 squares, 6, 7, Look here. You don't have to do that. You don't have to do that. When I counted down here a while to get the length between L and M, I was counting squares. I did 1, 2, 3, 4, 5, 6, 7, 8, don't it? I was counting squares, right? Now this shape, you look at it, most times what you do, and the questions most times will give you a shape that is of or is similar or close to one of your traditional trigonometry measurement shapes. Triangles, rectangles, circles, semicircles, sectors, trapezium, kites, shapes usually in one of those. So if you can count out the dimensions that you would normally use to find area of those shapes, like for example, if the shape is in the, if the area is in the shape of a triangle, and you can count out the squares to get the dimensions of that triangle, so you can go half base times height. You are free to do that. You are counting. You get me? So this, as I look at this, I see a trapezium. This is in the shape of a trapezium. So the parallel sides here, these are one and this one. And this is the distance between the trapezium, the two parallel sides. And if I know those dimensions, if I count off and know those dimensions, I can calculate that area. It becomes approximately the area of a trapezium. Okay, this side is almost straight over here, so. And this side over here is almost straight. That's like a trapezium. So I don't have to waste time going in there and counting off the individual squares in there. I need to count out the dimensions that I'm going to use to calculate the square. But I might say to the examiner, the area is approximately a trapezium of these dimensions. The area is this. Count out the LM, you count out the next side. That is, you count out the height, and you tell them that. So let's count off. What are the dimensions we need for the area of a trapezium? We need the length of the parallel side. This side we already know is 8 centimeters. 8 centimeters. This side up here is 2 centimeters. 2 centimeters. And the distance between them, you count it off. 1, 2, 3 centimeters. So the distance between the parallel sides is 3 centimeters. And I can leave these dimensions on my diagram. I said the area of the reserve is approximately the area of a chip is in the shape of a trapezium, as with dimensions shown on the diagram. I'll leave that. So I can see that down here. So I don't have to actually count the individual squares. It's a myth. You don't have to do that. They say count, you count. I've counted. I've counted to see that one side is 3. I've counted to see that one dimension is 3. I've counted to see that one dimension is 8. I've counted to see that one dimension is 2. All right. So see here for part 1. Let me do it right here. Part 1. Okay, I need to buy this. Part 1, which is right here. C1. Right? Shape is approximately a trapezium. With area half the sum of the parallel sides. The parallel sides were 3 and 2. No, not 3 and 2. 8 and 2. 8 plus 2. And the distance between the parallel sides was this 3. And those dimensions, I'm leaving them on the diagram. Times 3. So see there, the shape is approximately a trapezium with area. I'm working on the area now. Right? And this works out to be 15, right? Because this is 10. Half of 10 is 5. 5 is 15. 15 centimeters squared, as shown on the diagram. So I'm telling you that I'm showing these dimensions on the diagram. So anybody tell you have to go in there and count the half square them or not? No, you don't have to do that. Once the shape is one of your standard shapes, count out the dimensions for your standard shapes. If it's a rectangle, you count out the length and count out the width. If it look like an arc of a circle or a semicircle or a sector of a circle, You count off to see what the radius is, and so on. If you look like, so suppose the shape was like this instead. What the shape was something like this. Right? Let me put it in blue. So what the shape was like this. Almost like that. But this not so straight, it's kind of jagged. Right? But it's like that. Suppose that was it in blue. That will be a semicircle, half of a circle. What will be the radius? I just want to count out the radius. The radius will be this. Or maybe this. You want to see if it's a semicircle for real. You get me? If it was a semicircle, you count it off as a semicircle and do it that way. All right, so don't complicate it. If you see the standard shape that is in there, you use it. All right, so the area is 15 centimeters squared approximately. See, that's why I put the word here, approximate or estimate. See there? Word are very powerful, you know. So somebody might do it and get 14 if they try to count individually. Or they might get 14.5, or they might get 15.5. But because I use this method, I get in 15. But I can tell you, CXC looking for 15. That's why they give that kind of shape. But it's supposed to work out 15. I'm not supposed to work out to 15. They give that kind of shape because they want everybody to kind of get the same answer. They don't want to mark the paper and the body have 10 different answers. You get me? All right. So that is it. So this is 15 centimeters squared on there. Put on the centimeter squared. Put on the centimeter squared. Don't forget it. On the map. See, you know, calculating kilometers squared now, the actual area of the forest reserve. So this now we're going to use our area scale that we have. The area scale, the scale for area. We're calculating area now. We're going to use the scale for area and do it like a ratio. Use the scale like how we use ratio questions. Ratio questions can be done simply by multiplying and dividing by values to get the information that you want to see. So see it here now, for this part, I'm going to start with the scale for area. So on the map, to the land, or the island, I'm just going to write land. I have 1 centimeter squared. I'm using the scale for area to do it. And on the land, we worked out that the area was 0.5 squared, right? Here, so. See there? That was the area that was the scale for area now. The 0.5 squared is 0.25. So I could have written 1 centimeter squared to 0.25 kilometers squared. This is the same scale. So I'm going to put it, attach the box to it. This is the same scale. All I've done was work this out as this. So I'm going to start with this one. I'm going to start with this one here. See here, I'm going to start with it right here somehow. That's what I'm going to use. So it's 1 centimeter squared is 0.25 kilometers squared. This is my scale for area because I'm calculating area now. So using my scale for area, they will always give you the scale for distance. If somebody get creative, like if me I set an exam paper and I want to be creative, I give the students a scale for area. I say, okay, from that, what is the scale for distance? You have to square root it. You have to square root it. You get me? So if they give you the scale for area and you want the scale for distance from it, you have to square root it. But I've never seen that. They've always given the scale for distance because that's what happens in the real world. Scales are always for distance. But you have to use the calculate area as well. So we have to square the distance scale to get the area scale. All right. So we're gonna what now? We know that the area of the forest reserve on the map is 15 centimeters squared. 15. This is the answer up here. 15 centimeters squared. I know you want to know what this 15 centimeters squared is equivalent to. Simple. You want this 1 centimeter squared to become 15. So do the scale like how you do ratio. Multiply the ratio by 15. Just multiply this by a 15 because you want the map side to become 15. Then you will see what the land side is. Just multiply the scale by 15. And what that means is that multiply this by the 15 and get that the 15 centimeters square, which is the area of the forest reserve, is now this amount times 15. How much is that? A quarter of 15 is how much? 0.25 is the same as a quarter. What is that? 0.25 times 15 is how much? So like half and then half again. So is that 3.25? Somebody look up for me now? What is it? 3.75. 0 point, this times this one. 3.75. Right. So it's 3.75 kilometers. This is the answer right here. That's the area of the forest reserve. But I go to that, and believe me, the questions won't go past this. It's just that you might be working in meters, I might be working in kilometers. So the scale is of like a property, like a school property, like on a piece of land, like, you know, like on a piece of property, more than likely the distance is going to be in meters. But like a large space, like a city, or like this one was our forest reserve. So a large area, they give the measurements in kilometers. So they're either going to be working in meters or kilometers with the scale. Right? But you always start out with centimeters, because the map side must be in centimeters. You can't put meter per map. And you can't put that map have to be a very large map. You're assuming that the map is like on a piece of paper. You don't measure meters on a piece of paper. You use a ruler. The ruler not even 1 meter long, you know. The ruler that you use is usually what? Like 12 centimeters long the most. 8 centimeters long, don't it? For the paper that for working on paper, don't it? The ruler that come in a geometry, about 8 centimeters long or less, don't it? That's all? Good. Eh? 6 centimeters, yeah, not very long. That's the point. Right? 100 meters make a centimeter. So if a ruler is 10 centimeters long, let's think of it. If a ruler is 10 centimeters long, you have to put 10 of them together to make a meter. 10 times 10. You put 10 again together to see how long a meter is. You get me? But understand that? So you're not going to be using meter on a map. You're going to be measuring in centimeters on a map. Alright? Alright. That is that. One question down, many more to go. Alright. Somebody online have a question? You have to speak. I can't read anything, guys. I can't read anything. So if you write in the chat, I won't be able to read it. Because I'm looking at what I'm seeing on the screen is the same thing you're seeing. I'm not seeing the chat. Anybody online have a question? All right, nobody online up. Yes?
No, sir. No, sir.
All right, nobody online have a question. Who else in here have a question? Like we'll finish early to the man. Nobody have a question. Huh? June 2016 coordinate geometry. All right, let's go. June 2016 coordinate geometry. Well, like, I'm ready for the exam, man. Another question. June 2016. Right here. Coordinate geometry. See nobody join. June 2016. You know what number it is? Usually I wrote number 4 or so. June 2016, coordinate geometry. Da. This one? This one? Alright, no problem. Alright, let's do this one. Now, I like coordinate geometry questions when they give you the graph. Because a lot of the things you don't have to calculate. Like, for example, you don't have to calculate gradient. You can just count out the rise over the run between 2 points. And a lot of the times you don't have to calculate to see where the y-axis intercept is. You can see it. Like, for example, for this one, the y-axis intercept of this line is right here. So right here for that line, the C value right away is 3. So to get the equation of that line, for example, we'll actually give us the equation here. So let's not preempt the question. Let's not preempt it. What is that? It's a regular x plus y line. As you can see, x plus y equals 3. That we're doing linear programming. So you can see that it crosses the y-axis at 3 and crosses the x-axis at 3. The x plus y line, one of the regular lines that we use in linear inequalities, linear programming. All right, so the question gives us this diagram. It shows the graph of a line x plus y equals 3. And let's answer some questions now. It says determine the equation of a line which is now parallel to this one and pass through the origin. I can tell you something. You see all the x plus y line them are parallel to each other. They have the same kind of format. So let me just show you. The more things you know, the better, right? So for example, x plus y equals 5. It's parallel to this, you know. Pass through 5 up here and 5 down there. So you go like that. That is x plus y equals 5. So all of the x plus y lines are parallel. X plus y equals 2, pass through here and pass through here. See there? Parallel. This is x plus y equals 2. X plus y equals minus 2. Pass through minus 2 here, so, and pass through minus 2 here, so. X plus y minus 2. It will be this one. All the x plus y lines parallel. You have to try to do the mathematics the easy way, you know. So if you want to pass through the origin, then it's x plus y equals 0. That's what it is, you know. I pass through the origin. Remember, you know, if it's x plus y equals 5, it cross the x-axis at 5 and cross y-axis at 5. If it's x plus y equals 3, it cross x-axis at 3, cross y-axis at 3. If x plus y equals 2, cross x-axis at 2, cross y-axis at 2. If it's x plus y equals negative 2, cross y-axis at negative 2, cross x-axis at negative 2. So if it passes through the origin, let me say cross the y-axis at 0 and cross x-axis at 0, right here. So if you pass through the origin, it's at the same format, you know, x plus y. Because it's parallel to this, it's at the same format, x plus y. See here, and it pass through the origin. It go like this. See here, so the origin here, it go like this then. But it pass through the origin. At the origin, the x value is 0 and the y value is 0. So it's x plus y equals 0, that. See there? X plus y equals 0. That is it. So the equation of that line is x plus y equals 0. But maybe they want some work. What would I tell them? What would I tell them? Sometimes I can't do maths harder than it have to be done, you know. Believe me, it pains me to do a question more difficult than it needs to be done. Because they give you 2 marks for this. So I expect that maybe they wanted to show some kind of work. But question like this, don't need no work. All the x plus y lines are parallel to each other. And if you pass to the origin, it is x plus y equals 0. Because the x value is 0 and the y value is 0 at the origin. But let's say they want some work. All right, let's say they want some work. First, because them parallel, they have the same gradient, right? So let's say they want some work. So because you want a parallel line, one that has a gradient, same gradient as that. What's the gradient of that line? Negative 1. If you write in the form y equals mx plus c, you carry over the x, you will get minus x plus 3. This minus x is same as minus 1x. So the gradient of those parallel lines will be negative 1. See that? We'll also get the gradient another way by counting off the rise over the run on the line. See it here? Count off the rise over the run. Look, between 2 points. So you can use these 2 points. Easy, close. Any 2 points. And when you count off gradient, go from left to right. So to go from this point to this point, I would have to rise negative 1. I would have to come down 1. That's negative 1. Then I have to run 1 this way. See that? Run 1. So my gradient will be rise negative 1 because I came down 1 over run 1. Run 1. Negative 1 over 1 is just negative 1. That's another way we could get it. So the gradient is negative 1. And then pass to the origin. Once the line passes to the origin, the c value is 0. Pass to the origin, the c is 0. So this line that you want, it has a gradient which is same as that. So the gradient of the line that you want, the gradient is negative 1 and the c is 0. So the equation using y equals mx, when you pass to the origin, you don't need to put no plus c because you pass to the origin. Lines through the origin are of the form y equals mx. Lines through O, or the c is 0. Lines through the origin will always have that format. Y equals mx. Lines to the origin will have this form, y equals mx, and the m is this. So the equation is y equals minus x. If I transpose the minus x, it becomes x plus y equals 0, as I said before. All right, but because them say give it some, I'm going to show somewhere. But I could look at it and know that it's x plus y equals 0. It's not complicated. Next question said, they want the perpendicular, the line that is perpendicular to the line, this one, and pass through the midpoint of AB. That line is y equals x. You can just visualize it. It's y equals x. Look here. It passes through the midpoint between A and B. The midpoint between A and B is very easy because A and B are your x and y axis intercept. Right? So you want the midpoint between these 2 points, where these 2 points is 3 this way and 3 up this way. The midpoint is going to half those distances. Half the distance here, I want the midpoint, so going halfway. Half this way, which is 1.5, and half this way, which is 1.5. So it's 1.5, 1.5. So the midpoint is right here. Midpoint is 1.5, 1.5. I can't bother do the mathematics harder than it has to be done. That's where the midpoint is. And if the line that you want runs perpendicular to that, so you go like this. That is it, you know. It's going to go like this. That's the line y equals x. So you can look at it and know. But let's say I have to calculate it. Let's say I have to calculate it, right? So firstly, it passes through the midpoint because it is a perpendicular bisector. That's what this means, you know. It's perpendicular and passes through the midpoint. It is a perpendicular bisector. So what is the midpoint? If we were to calculate the coordinates of the midpoint, let's do it by calculation now. So remember, the midpoint is like an average point, right? So A is a point. A is the one on the x-axis. No, the one on the y-axis. So A is a point 0, 3. And B is a point 3, 0. So the midpoint, let's call the midpoint M. Let's call the midpoint M. So M is the average of the x values. That is the 0 plus the 3 over 2. If you want to show some work. And the average of the y value is 3 plus 0 over 2. 3 plus 0 over 2. So you see that the midpoint becomes 1.5, 1.5. If you want to show some work. So we have the point that the line passes through. Now, because it is perpendicular to this one, it has the negative reciprocal gradient of it. So remember, the gradient of the first line is -1. Let's call this the second line. Let's call this line 2. That we want. Let's call it line 2. So the gradient of line 2 is -1 over the gradient of line 1. Negative reciprocal. So somebody asked me about this yesterday. I can't believe it. If you have two perpendicular lines, they have what we call negative reciprocal gradients. If you know the gradient of one, and you want to find the other one, you flip the one that you have and change the sign. Or you put -1 over the one that you have to get the other gradient. But this calculation is done quickly by flipping the one that you have and change the sign. We had to do this from last year. And somebody asked about this yesterday. What's so it go? Parallel lines and perpendicular lines. You're not supposed to give nobody problem at this level. The lines parallel them have the same gradient. If them perpendicular, they have negative reciprocal gradients. Meaning the one that you have, you can flip it and change the sign. So for example, this one that we have originally is -1. You can put the -1 under here if you want, you know. And put -1 over -1, give you a +1, you know. Right? But we can take the -1. I don't even like to do it with a number like this. Let's say the gradient was 3 over 2. I want a perpendicular gradient to this one. You flip the 3 over 2 and it becomes 2/3. And because this is positive, you change it to a negative. So these two are perpendicular gradients now. Flip the one that you have and change the sign, you get the perpendicular gradient. If you multiply them, you get -1. If I multiply those two values right now, I get -1. See it? When you multiply perpendicular gradients, you get -1. Let's do another example. So the gradient of a line was 3. I want to find a perpendicular gradient to that 3. You think of the 3 as 3 over 1. You flip the 3 over 1, you get 1 over 3, and you change the sign to negative. So these two are now two perpendicular gradients. Flip the one that you have and change the sign. You get the other one if the lines are perpendicular. If the lines are parallel, the gradients are the same. You know, the no. Another thing, if two lines perpendicular, guys, one gradient have to be positive and one have to be negative. It's them perpendicular. Right? Except for the x-axis and the y-axis. A vertical line or a horizontal line. Because a vertical line, a horizontal line has a gradient of 0. Horizontal line, there is no rise. From here to here, on a horizontal line, there is no rise. So the rise is 0. So it's 0 over the run. Must equal 0. So horizontal lines have a gradient of 0. Vertical lines have a gradient of undefined. So if it's a vertical line, to go from this point to this point, the run is 0. There's no run, there's only a rise between these 2 points. So it will be the rise over 0, because the run is 0 on a vertical line. Once you divide it by 0, you get it undefined. So the gradient of a vertical line is undefined. It's so steep, vertical line is so steep, you cannot say what the gradient is. So those are the only 2 lines we will say, all right? Those are horizontal line and a vertical line. They are perpendicular. That's the only time we say, okay, if one positive, the other one negative. Once the line have a positive gradient, the perpendicular one has a negative gradient. If one line has a negative gradient, the perpendicular one must have a positive gradient. And it is a reciprocal, the negative reciprocal. All right, I'm just saying this because this is the last day we're doing this for and stuff. So this gradient is going to be 1, guys. The gradient I want is going to be 1. If you take the negative 1, same as negative 1 over 1, you flip it, it's going to come as 1 over negative 1. Change the sign, going to become 1 over 1, which is 1. It's too easy. You can't bother do them something there. This is just going to be equal to 1. So I can take the negative 1, you put on the yes for the M1. Negative 1 over negative 1 is 1. So the gradient of the line that you want is 1. So like you're using this gradient and this point now, because you're trying to do it, that's if you want to do it the hard way. I just showed you the easy way to do it a while ago. And say the answer is y equals x, right? But if you want to do it the hard way and use this gradient and this point, then we will use the BFF formula for the equation of a line, what we call the gradient point form. Some people still use y equals mx plus c. Use the gradient and this point to calculate the c, that's okay. But I prefer the way that is on your syllabus, which is this format of a line. Y minus y1 equals the gradient into x minus x1. I'm not going to say 1 this time. The reason I write it this time because that's what is on the syllabus. I'm going to say m, because m is the points. I'm going to put m right here, m right here. Meaning I'm using the y value at m here, and the x value at the point m here. M is the midpoint. So I put in those values. Remember, the gradient of the line is 1. What you're going to do? You're going to get y minus 1.5 equals, the gradient is 1 out here. So 1 into x minus 1.5. So you see that the 1 times this leaves that as the same thing. So the minus 1.5 and the minus 1.5 cancel each other. And you end up with an equation just y equals x, which is the answer. But it's too easy for sure no work. I tell you, it's too easy for sure no work. Just look at it and know that is y equals x from the get-go. So the answer is y equals x. I don't even want to leave all the working up on the screen. I like you basically do more than you needed to. And I like the mathematics anyway that is more difficult than it has to. All right. All right, what's the next question? I think that one finishes that one. That's all I wanted, the line part. This is the quadratic part. Quadratics. Huh? Okay. Come on, find a more interesting line question and come again. I want the 2 basic. Yes? No, tell me the year. January 2023, the vectors and matrices. All right. Hold on, let me see something. Let's check in. All right. Let me see if anybody online saying anything. Let's check. Remember, guys, online, if you have any questions, you can just say it. All right, nothing, let's go over the yeah, over this one. All right. Hey, nobody start, nobody start. All right, guys. Which question is now? 2023? January 2023. January 2023. Hey, stop now. I'm running outside, man. But I come very upset from yesterday still, you know. Stand relax. Which number is there? 10. This one, all of it? All right. Matrices. And over here is vectors. You know the question one night? The question one night. And I'm full of the question. Where were you? The question the other night, you know? You know the question last night? Last night. Huh? No, man, no have a video for this, man. You can't do this. You can't do this last night and come back this morning and come do this again. Last night, you do this. No, man, I'm not saying. I can't wait. That's inefficient. That's inefficient work. I can't do something last night. And the video is there. And come back and do the same thing this morning again. Oh, man. All right, number 9. Let's go. Come on, give us something different. I don't want a question from yesterday, gentlemen. That don't make no sense. All right, this question right here. This question says, double X and U are points on the circumference of a circle. TV is a tangent to the circle at U. This is the tangent out here. This is the point U. It says this is a diameter. UW is a diameter. And this triangle is isosceles right here. Is isosceles, right? So those two sides are equal. And so the angle opposite this side, which is this one, is equal to the angle opposite this side, which is that one. So those two angles are equal because it is isosceles. All right. And the question said, use appropriate theorems. Using appropriate theorems, state 3 reasons to explain why the measure of angle Z, that's this angle right here, so, is 45 degrees. All right. 3 reasons why that angle is 45 degrees. I must state the 3 reasons. Now I'm going to support my reasons by finding some of the angles up here first and leave them on the diagram. It's a part of my solution. All right. So I'm going to put some of the reasons on the diagram first and then state some of the rules that will cause this angle then to be 45 degrees. That's the approach I'm going to use. All right. So first thing, I'm going to tell him that this angle right here says 90 because it is subtended by this diameter. First thing I'm going to say. This angle right here says 90 degrees, angle subtended by diameter. So all this is a part of my answer, part of my solution. So I'm going to indicate that this angle right here is 90 degrees because it is subtended by the diameter. First thing. Then I'm going to tell him that these two angles are 45 degrees. This one and this one. Because that's an isosceles triangle. And total angle in an isosceles triangle is 180. And because these two equal, then they're each 45 degrees. So I'm going to say something like over here, this angle is 180 degrees minus the 90 degrees that we already have here. And we're dividing that by 2. That gives us 45 degrees. All right. And let me put this the other way. So we can have space. So let's put this way and shift this down. So this is because total angle in the isosceles triangle is 180 degrees. Total angle in the isosceles triangle is 180 degrees. So the word isosceles will account for y divided by 2, and then the total is 180 will account for this 180. All right, and this angle is also same thing. It is this angle right here is the same thing. 180 degrees minus the 90 degrees divided by 2, which is 45 degrees. All right. Then I'm going to tell him that this angle right here says 90. Fill out all the angles so I can reference them. This one. Because the angle between a tangent and a radius. So this angle right here now is 90 degrees. Because the angle between tangent and the radius. And between a tangent and a radius is 90 degrees. So this angle right here is 90 degrees. So now that I've populated those angles, I can tell him these down here, right? So the first reason why I'm going to tell him that this angle is 45 degrees, I'm going to say that this angle is 45 degrees because the whole of this is 90 and in here so 45. Because the angle between this tangent and this radius is 90 degrees. They did not name this point. I'm going to put it on the diagram and name it O. So I can reference it. So I'm going to say that angle Z will be equal to 90 degrees minus 45 degrees, which is still 45 degrees. That's my first reason I'm going to give them. And the reason for that is because the angle between tangent. Tell them which tangent. Tangent, that's this tangent, UV, and radius. Which radius? UO is 90 degrees. That's the reason I'm subtract this 45 in here. And don't tell me that it's a 45 already, you know. So this is good enough now. The other reason I'm going to give him is the alternate segment rule. That angle between a tangent and a chord is equal to the angle subtended by the chord up there, which is 45 degrees. So this angle out here that we want is equal to the angle up there. Alternate segment rule. I'm going to give him now. I'm going to tell that it is equal to the angle OWX, which is 45 degrees. So again, the angle Z that we want, angle Z is equal to angle OWX, angle OWX, this one, which is 45 degrees. Why is that? Because the angle between a tangent and a chord is equal to the angle subtended by the chord. Angle between tangent and chord equals angle subtended by the chord. And then the third reason I'm going to give is that the angle is 45 degrees. This total angle on this straight line through this point is 180. Everything over here is 180 degrees total. So since right here is 90 and inside here is 45, this angle has to be 180 minus the 90 and the 45. That's going to be 45 as well. So I'm going to say as well that the angle that we want, Z, is 180 degrees minus the 90 degree angle that we have set it over here, and 45 degrees inside here, subtract that as well. That gives us 45 degrees. And because the total angle on the straight line, V, U, T through U, is 180 degrees. Total angle on the line, V, U, T through O, through U, through the point U, is 180 degrees. Those are your three reasons. But it helps to populate the diagram first, so you can just reference them. You get me? It's easier to do it that way. That's what I found with this question. It's easier to actually give the explanation by populating the diagram and leave all these things on the diagram as well. Don't take them off. They add to your reason. All right? So get one like that. I think I suggest you approach it that way. All right, next question. Gives us this diagram. It's a circle theory question. It says, diagram below shows a circle with diameter KF. That's the diameter right here. Pass through the center. Remember, diameter subtends 90 degrees at the circumference. It says line EFG is a tangent out here. That's a tangent. And it says the points F, H, and K lie on the circumference. So F, H, K, and J. F, H, K, and J. They lie on the circumference, as you can see. So what they have described up here is shown on the diagram. And they have not given us these angles, but they are on the diagram. So we're going to work with them. It says, by showing each step in your work where appropriate, find the value of each of the following angles. I want angle X. Angle X is the one right here. Now that one is easy. What's the thought process in finding that angle? Remember, find the chord that is subtending the angle. So if I want to find the chord, if I want to find this angle, and I can't see what it is right off the bat, I find the chord that is subtending it. How do I find the chord? Go back along the sides, forming the angle until you reach the circumference. Go back around the other one until you reach the circumference again. I'm looking for the chord, which is this. That's the other point. So if this line wasn't there, then this arc would be subtending the angle. Because they gave us the chord is there. This is the chord. I'm going to work with this chord. That chord is subtending that angle. This blue chord is what is subtending that angle. What else is the chord subtending? What else is the chord doing? The same chord is subtending another angle up here in the same segment up here, the circumference. The same blue chord is what is subtending this angle up here. Same blue chord. And there's a rule that says angles in the same segment subtended by the same chord are equal. So it means that the X and the 56 equal. So the X equals 56. Same segment rule. They are subtended by the same blue chord. All right, both of them. So I'm gonna write that. So the angle 56, angle X, sorry, is equal to 56 degrees. So x degrees is 56 degrees. Now, because I put the degree on the x is just 56. Without the degree, the x is just 56, but the angle is 56 degrees. What's the reason? Because angle in the same segment are equal. So angles in the same segment are equal. Now, this is usually enough. We could continue and say are equal when subtended by the same chord or arc. By the same chord or by the same arc. But I think if you write this, just this, angles in the same segment are equal, 6 will give you a marks. Angles in the same segment are equal. They give you 1 mark for that. All right. Next part wants angle Y. All right. So I'm erase these now. So we now know angle F, angle X, right? And now we're trying to find angle Y, which is this angle. Right off the bat, remember this is now 56, you know. Right here is 56. Right off the box, I see that Y as an external angle of this triangle. Or no, it's an external angle because it is on the extension of one of the sides of the triangle. An extension, and it is the angle made with one of the adjacent side to the triangle. So it's an external angle or an exterior angle of this red triangle. That blue angle is an exterior angle to this triangle. There's a rule that says exterior angle of a triangle is equal to the sum of the 2 opposite interior angles. You have to know that rule. So that blue angle is equal to this blue angle, which is the Y, is equal to the sum of these 2. This one plus that one. Those are 2 interior angles opposite to it. So that Y is equal to the sum of those 2. You're going to add them. Simple as that. The exterior angle of a triangle is equal to the sum of the 2 opposite interior ones. They are opposite because the one that is on the same side of it as the Y is this one right here. All right? That's the one corresponding to the Y, the interior one corresponding to the Y. So the opposite ones are these. So you add them to get the Y. So the Y is equal to 56 plus 19. So the Y degrees is equal to 56 degrees plus 19 degrees. How much is that? 75 degrees. Reason? That's Y degrees. So the Y is just 75 if you take off the degree. All right. Reason is that the exterior angle of a triangle is equal to the sum of the 2 opposite interior angles. Exterior angle of a triangle is equal to the sum of the 2 opposite interior angles. That's the best way to do a question. And that finishes. One partito? One partito? This is, huh? No? All right. Which question next? Nobody online not give me no question yet, you know. They're joking. I could have finished early today, man. So people that come with a lot of questions. and put the meeting ID here. So, what do I add to the chat? What do I add to the chat here? Chat. Put the meeting ID. Oh, I'm ready for the exam, man. I know my question. Hold on a second. Somebody asked me for the meeting ID and thing. Hold on. Just put it here. Meeting ID and password. 852 4711 0057. What is this? Hold on. Anybody else have a question? Huh? January 2018.
So,
Hold on. Yes?
can you do January 2019, question 6?
All right. One second. I'm trying to send a message to the chat right here. Let me see. Okay, so let me try out this. Just give me a second, please. Oh, down here I need to put it. Okay. Passcode 194916. All right. I'm gonna do the online. Somebody online does request one, and I'm gonna come back to yours. Yeah. What number you said online?
2019, January, question 6.
All right. January 2019, number 6. Where are you? January 2019, number 6. All right, this is it. This one. All right. Now you're talking. Ask good questions, man. I like this question. All right, let's do this one. All right, beautiful. Because they setting question like this quite frequently now. Sometimes they give it this kind of shape, other times they give it like a box. And I tell you the box have a thickness, and you know, and it has a thickness throughout. I don't know if you remember, there's one with a silver box, and there's another one that's set with a trough. Like remember? Similar questions, you know. This time now they give this thing, but they're all similar. All right. All right. So basically some internal volume minus external volume to get the volume of material. And then invariably they ask about some mass or some density thing. Oh, that's all these questions always are. It's an external volume minus internal volume to give the volume of material in the box. So it's like this container is cylindrical. There's an empty space inside here. There's a cylindrical space inside here. And you need to find that internal volume. You need to find the volume externally of everything to get the volume of the material. The volume of the material that makes up this thing. Whatever the material is, that's how these questions always are. And then they're going to ask you something a bit to some relationship between volume and mass. Volume and mass. All right? All right, let's go. So this question says, the diagram below not drawn to scale shows a open, see, keyword is open. Open cylindrical container made of metal with a circular base, and look here now, see, uniform thickness throughout. The thickness of the material is uniform throughout. So just think of a container, like a cup or a flask or something. It has uniform thickness throughout. This is that thickness throughout, right? It says the length of the container from the bottom to the out, from the top to the outer bottom is 120 centimeters. That's this. So from the top all the way down to the outer bottom is 120 centimeters. But no, that some of the material is going to be down here as well. And it has a thickness, right? Because it says throughout. All right? Then we continue. It says the inner and outer radii are 14 and 15 centimeters respectively. So it's like from the center of the cylindrical opening here to the inner radius, that's 14 centimeters, and to the outer radius is 15 centimeters. So that is telling us that the thickness of the material is 1 centimeter. And because it has a uniform thickness throughout, right through the container, the thickness is now 1 centimeter. So we have determined that the thickness of the material is 1 centimeter by virtue of the inner radius and the outer radius having a difference of 1 centimeter. So the thickness right here, for it to zoom it up, the thickness right here, right inside here, so is 1 centimeter, 1 centimeter thickness. It is the same thickness that is at the bottom here. 1 centimeter. 1 centimeter thickness at the bottom. Right? And so internally, the cylindrical space internally is 19 centimeters. Because externally it is 20. You subtract the 1 centimeter down here to get the 19. Oh, 119. 119. Yeah, thanks. 119. 119 centimeters is the internal length of that cylinder. And internal radius is 14. All right? So that's the first thing you want to identify. Question said, draw a cross-sectional view of the container showing the measures of the inner and outer radii. So basically the inner radius is 14, the outer radius is 15. You need to draw concentric circles, circles with the same center. One is 14 and one is 15. So you could, I would say, use your compass, open it to 7 centimeters and draw the circle. They open it to 8 centimeters and draw the next one. So let me just do it still. Since we're here, let me just do it. Let's not assume anything. Let me do it and show you how I use the compass. Because they say draw. Then it was a sketch. So once you see the word draw, you do it properly. Sketch means that it don't really matter the accuracy of it. Draw, once you see the word draw, looking for accuracy. Right? Scale and proper. All right? Word draw. So let me show you what you would do. So what they have done, they have sort of tied the construction in this question here. So where are you? Right here. So what I would do to draw that those concentric circles, I'll show you. I'm just going to open this fully and just draw the 14 and the 15 and then come back. All right. So I will use a ruler. And use the compass. And I need 14. But you see that my compass can't open the 14. Cannot. Can't go so far. But I'm just going to use 4 and 5 just for illustration purposes, right? I'm not going to use 4 and 5 just to illustrate it, right? So I'll open it to 14, but I'm just going to use 4. Because my compass on this device can't go all the way to 14. And I would then remove the ruler. Let's give this a color. And I would lock it. That is my center, right? And I would basically just make a circle. Make a circle. That's 14 centimeters right now. And then I would bring back my ruler. And I know I want it to be 15. So I would open it back to 15 now. I'm not moving the center. Mark it at 15. Lock it. Let's draw the next one. So the key thing is that it must be concentric. Must have the same center. All right. And then we'll kind of show the measurements on it. So I will draw a line. Let's put it in black. from here to here, and draw another one from here to there. And we'll tell the examiner that this one is 14 centimeters. This one is 15 centimeters. That will be my cross section. But I go to that. Simple as that. All right, that's what I would do. All right, that is that. It gone. All right, it gone. Well, you saw it, right? You saw it. So let's get back to this. Let's get back to the question. So basically, what you just sketch it out on this. You basically have two circles that are concentric, same center. So I do these dimensions in red. From the center here will be 14 centimeters, and this one will be 15 centimeters. All right, that's what I would do. All right, next question says, show that the capacity means volume to full. That's what capacity means. Volume required to full of the container is this. So the capacity becomes the inner volume or the volume internally. All right, so I'm going to say this capacity, I'm going to call it something. I'm going to say it is the volume internally. It becomes a cross-sectional area times the length internally. So cross-sectional area is pi r squared. I'm going to use a small r for this inner radius. So it's pi r squared h internally. All right. Let me put I on these for internal. So it's the internal radius and the internal height. So this is the cross-sectional area pi r squared, and this is the height pi r squared h. We're using the internal dimensions for the space internally. But the capacity now is what's going to fill the space inside. And the space inside is this white space here. This white space inside here that we want to fill. All right. So the inner radius is 14 and the internal height is 119 centimeters. They tell us to use for pi. Pi is 22/7. So ready, let's go. So these numbers then becomes the pi is 22/7 times the internal radius is 14, that's 14 squared, times the internal height is 119. And that's going to give you this figure when you calculate it. Let's do it. Let's get a calculator here.
So where did you get 119 from?
You want you listening? I explained it. You have to listen. I was explaining it. So let me show you again. So what we said is that the question said that the thing had uniform thickness throughout in bold letters. And because the internal radius is 14 and the external radius is 15, we gleaned, and it was concluded that the thickness of the material is 1 centimeter. So that 1 centimeter thickness goes throughout the container. It is a container, so it must have a bottom. It must have a bottom, something covering off the bottom. Bottom section down here covering off the bottom. If you do have a bottom and you pour something in there, it's just going to run back out. Because it's a container, it has a bottom down here. And did they say it was an open container? Let me see. See, an open container. It's open, but it is a container. So since it's a container, it must have a bottom. The bottom must close off. It closes off with the same material that we see on the side here, because the question said in bold letters that it had uniform thickness throughout. So the thickness of the bottom of the container that is closing off the bottom of the container is the same thickness of the sides of the container, which is 1 centimeter. Then if the overall height of the container from the top to the bottom external is 120, and the thickness of it at the bottom is 1 centimeter. The thickness of the bottom down here is 1 centimeter. Then the overall 120 minus this one is giving us the internal 190. So internally, from the open top to where the bottom stops on the base is 119. That's where 119 comes from. Get
Okay,
it?
thank you, sir. Yes.
All right, good. Don't feel to ask a question. Don't mind me here. Don't mind. Ask me a question. I'm saying me. Don't mind me. All right, but just listen. All right, so that's the 190. So when we do this calculation now, we're gonna get that dimension. So it's a fraction 22 over 7 times 14 squared, and then we're multiplying that with the 119, and voila. It's always nice when you do something and get the exact figure that they tell you. 73304 centimeters cubed is that internal volume, which is the capacity required to fill the cup. All right. Next part now says, determine the volume of the material used to make the container. They're talking about the shaded material here. The material, the actual material, this. The material, like the metallic thing that is making the cup. So that becomes the outer volume, the volume of everything, including the inner space and the material. The outer volume, the volume of the whole thing, minus the volume of the space inside it that we just calculated. That gives you the volume of the material that made the cup. Right? The rim and so on, right? And the bottom, right? Good. So it becomes the outer volume minus the inner volume. That's what gives you the volume of material. So the volume of material, let's write it like this. The volume of material becomes equal to the outer volume minus the inner volume, VI. So we have the inner volume here already, this. So what is the outer volume? The outer volume is calculated the same as the inner volume, but we're using the outer dimensions, right? Using the outer dimensions. So it's still pi r squared, but we're using the outer radius now, the 15. And we're using the outer height as well, HO. Using the outer dimension for the outer volume. And you're subtracting the volume that we have already, which is a 73304. That gives you the volume of material. Volume of everything minus the volume of the space inside. Now, whether they give you a box, a silver box, I remember there's a silver box question, I think that was in 2016. Recently, there was a trough. And some other time they give other shapes. Whatever the shape they give you, when the volume of the material is the same thing. The volume of the outer volume minus the space inside give you the volume of material. You can look over a question like this. I tell you, they like to set questions like this. All right, so that outer volume now, this is 22 over 7 again, times the outer radius is 15, so it's 15 squared. The outer height is 120, and it's subtracting this still, 73304. Put everything in the calculator one time now. So it's gonna be 22 over 7 again, times 15 now, 15 squared times 120, and you're subtracting, I don't have to show the figure, I can just write one figure, subtracting 73304. So I wrote the wrong thing, 73304. So I get an 11553. So make sure we put in the right figures. 22 over 7 times 15 squared times 120 minus 733. All right. So I'm going to put 11553 centimeters cubed. That is more than 3 significant figures. So I'm good with that. I don't have to put the decimal places there. That is it. So far, so good. Online?
Yes, sir.
Beautiful. All right. The next part now tells us, given that the density, every time they give a question like this, always coming apart like this. It is not complicated. Given that the density of the material used to make the container, that is the volume, remember we just calculate the volume of the material here now. So the material here, which is some thin material or some metallic material, let's say, right, has this density. All this density means, in simple language, is that 1 cm cube of the material is equivalent to 2.2 grams of the material. That is all this thing means. 1 cm cube is this amount of grams. So 2 cm cube is 2 times that. 3 cm cube is 3 times that. So therefore, this amount of cm cube is that amount times that. To get the volume of the metal, right? The total volume. But understand that? It's not complicated. So this formula they give you here, like it's physics we're doing, we don't need it. The density equal mass over volume. We don't need that. They didn't have to give you this. And there are other questions where they won't give you that. They will just tell you this. And you still have to interpret it. You get me? So they are inconsistent that way. They'll ask a similar kind of question and don't give you this relationship to use. What they have actually given us is the density. We're not going to do it like physics and say density equal mass over volume. We're going to do it a way where if they set the question another time and don't give you this, you can still do it using this simple kind of reasoning approach. You have to understand what this means. 2.2 kilograms per centimeter cube simply means that 1 cm cube has 2.2 grams in it. 2.2 grams. All right? Let's say determine the mass in kilograms. That's the only thing now. They give us this in grams, but they want the mass in kilograms. Remember, it's 1,000 grams make a kilogram. So we're going to calculate the mass in grams first, because they give us this information in grams. And then get it in kilograms, they divide by 1,000. Or 1,000 grams make a kilogram, right? So what is the mass of the material? So if 1 cm cube is this, I'm going to use this ratio. It therefore means that this amount of cm cube, 11553 cm cube, is equivalent to this amount times that, grams. All right? Don't complicate it. Keep it simple. Equal to 11553 times 2.2 grams. You wrote that out, you're going to get it in grams. So it is 11553 times 2.2, and that is 25,416.6 grams. I want it in kilograms, we divide by 1,000. I want it in kilograms. So you see, another question, you know, they might tell you that 1,000 grams make a kilogram, you know. Another question might tell you that, you know. Just as though in the map question a while ago, they told us that 100,000 centimeters is a kilometer. Another question they won't tell you. You have to know. Right? So you can't rely on these things. I don't assume that these things will be given to you all the time. But if you want this in grams now, you divide by 1,000. So divide by 1,000, basically move the decimal point 3 places to the left. 1, 2, 3. To divide by 1,000 to get it in kilograms. So I'm going to write 25.4166 kilograms. But I just leave it as 3 significant figures here, but no problem. That is it. What about that?
Yes, sir.
Beautiful.
So by
All
chance, can you do question 5 in this paper as well?
All right. Hold on. Somebody wants question 5 on this paper. All right. So since we're on this 2019 paper, which paper you have? 2018. All right, we're going to go to yours. We could just exhaust any question on this paper anybody have. So, and then we'll just move to the 2018 paper on the yours, right? So we're doing another question next. But let's just, somebody want number 5 on this as well. So let's see. Number 5. Number 5. All right. So this looks like another question is this. All right, let's see. It's like some statistics business. Question says, a survey, statistics. A survey was conducted among 48 persons to find out what mobile phone they use. And the table shows the results. So 20 persons use Wiretech, 12 persons use Digilec, 10 persons use O-phone, and 6 persons use other. So like cable and wireless, it's like Digicel, it's like O-phone in England, I think. It's others. Anyway, it says, if this information is to be represented on a pie chart, what is the angle for the sector that will be used to represent O4 right here? So remember, the total is 48, you know, it's 48, right? So in terms of the total, it is 48, right? So put in here for the total, it's 48. Now, how do you get the angle? The angle for a sector must be proportional to the 360 degrees. So it's like a fraction. What fraction of a 360 degrees? The fraction is represented by the fraction of this out of the 48. That's a fraction of the 360 degrees. Remember, you're taking the full 360 degrees in a pie chart and break it down into sectors. And you want to get the sector angle. The sector angle is in the same proportion as the fraction of the total data that each represents. That's what I'm trying to say. So for example, the angle for this one is going to be 10 out of the 480, out of the 48, multiplied by 360. That is the fraction of the 360 that the O phone will take up. Same fraction. That's an easy way to explain it. Leave this. So the total here is 48, right? This adult to 48 for real? Yes, this one is at 30. This adult at 18. Good. So that's 48. So the O phone is going to be 10 over 48 times 360. So the O phone angle, let's call it O phone angle, is going to be 10 out of 48. That is a fraction of the data that O phone represents. You apply that same fraction to the total 360 degrees to get what angle the O phone will be in your pie chart. What angle the sector that O phone will be. So you multiply this by 360 degrees. 360 degrees. That's what you do. Simple, simple, simple. And kind of makes sense. So you're working that out. 10 over 48 times 360. All right, so let's do it here. So it's 10 over 48 times 360. 75 degrees. So you're going to put 75 degrees in the O phone sector. 75 degrees. All right, I like doing this question because they don't set these things very often, like pie chart. But you know, when you get a pie chart, it's easy. You want to get it right. All right. So that's the O phone. But I know we're gonna need the rest of them, right? We're gonna need the rest of them. Now watch this now. Even though they ask us for the O phone, and we're giving them the O phone as our answer. Don't need asking us to draw the pie chart. See that? So just give that figure 2 marks, you know, just in case you know I get nothing else right. But you have to know, so you have to get the other angles to draw the pie chart, right? So you're gonna need the sector angle for the rest of them. This one, and this one. Now, this one kind of easy to get because look at it. This is just 2 times this. So the angle is going to be twice this angle. Make sense? So that always kind of sets up a way that if you work out one, you can know the others, right? I can know some of the others. So since 10 degrees, so since 10 processes O phone will occupy 75 degrees, then 20 is going to occupy twice as much because 20 is 2 times 10. It's it? Same ratio, right? So that's actually work it out. But if you work it out, you can still get the 150 if you want to work it out. We must see the relationship between those numbers. And then what I can do is calculate for 6. And then this is twice 6. Whatever I get for the 6, I'm going to double that, and that is the amount for the 12. You understand what I'm saying? So they usually kind of set the question that way. So you don't have to work out for all of them. You work out for 1 and can get the rest. I work out for 2 and can get the others, right? So that's what it normally is. So based on this information, we can just put in this. Let's put this part in purple. So we know that the wire tech is going to be 2 times this. So the wire tech angle, just put W tech. The W tech angle in the pie chart, because we're not going to need it to choice. It's going to be 20 over 48 times 360. It's going to work out to twice this because we're using twice this number here, which is 150 degrees. 150 degrees. You're going to calculate for the other and then double that for the digit, right? Let's just calculate it. So the others are other angle for others is going to be 6 over 48 times 360. What's that? 45? You sure? Yeah. All right. And then this is going to be twice as much, right? So GGLEC, let's call it DLEC. DLEC angle is going to be now 12 over 48 times 360. Because 12 over 40 is a quarter, right? So you're going to get 90, right? And then remember, these must all add up to 360. That's an important thing. So what you do, you kind of double check and make sure 75 plus 150 plus 45 plus 90, 360. Right? That's a double check it, make sure. All right, so your pie chart have a total of 360 degrees in it. Then them say now, using a circle with a radius shown, and I've seen questions where they tell you to draw a pie chart and tell you what radius to use. So I say draw a pie chart of radius 5 centimeters. So you know you have to open your compass to 5 centimeters and draw the circle. And you start. You get me? The radius is 5 centimeters. But this one starts for you. And they start with one of the lines. And that's how you have to start anyway. If you were starting from scratch, you have to draw the circle first and then draw a line. And start from that line. Right? Draw a radius line to start. But anyway, they want us to represent the pie chart. So using the circle below, with radius shown, represent information on the table on a clearly labeled pie chart. All right, so I'm gonna do this on a construction sheet over there as well, just to show you the proper way to do it, because this is another thing you have to do accurately, right? So let me do it over here. Let me do it over here. Show you what you would have to do. All right. What's happening here? Thing going off. All right, good. So clear. All right, so I'm gonna draw a circle. I'm just gonna put a circle to start. I'm just gonna put a circle to start, right? And show you kind of how you would proceed in the exam room. All right, so I'm just gonna draw a circle here. All right, and then I'm gonna draw a line that they have similar to theirs. So let's say we're starting like that, right? So you basically want to represent each of these angles now, these. So I want this one first. I'm going in the order of the table. So I want the wire tech first. I'm going to do the wire tech. And you decide where they're going to measure the angles, clockwise or anti-clockwise. It don't really matter. We're bringing in this thing, a protractor. You're going to use that to measure your angles. All right? So I want 75 degrees. You have to position that on the diagram properly, position it properly on the diagram. So you put the eye on the point. See the way the eye is? Right in the cross. But I can see that. You're not putting the bottom of the protractor on it. A lot of people do that. They put the bottom of the protractor on it like that. No, you put the eye on the point where the horizontal line and the vertical 90-degree line cross. That's where you put it. And protractor, on some protractor, they have a little sink right there on it. And you rotate the protractor so that it passes through 0. You're measuring from the 0. Look at the protractor. It has 2 scales. It has a 0 scale and a 180-degree scale. You're putting it on the line that passes through 0. See there? See that line? The line that you're measuring from passes through 0. Then you're measuring the 0 scale. The 0 scale and you have the 180 scale. So the 180 scale counts down, the 0 scale counts up. We want to measure 75 degrees. All right, so make it a little smaller. So what you normally do is put a mark and then draw a line out to that mark. That's what you normally do, right? So at the edge of the protractor, we're gonna put a mark. So 75 will be somewhere way over here. So look at it, way over here. So you can see it? I'm gonna put a little mark right there. That's my mark for 75. But I see that? The next angle is gonna be from that line. So you have to draw that one first, you know. So you move the protractor and draw that one. That's the first sector. So you draw your line out to there. That's a 75. I want to stop it right there. Draw a line out to that mark. That's my first one. That's 75 degrees, right? So that's 75 degrees. I'm just going to put WT for wire tech. WT for wire tech. Then I'm measuring now from that second line that I've drawn. The next angle, hold on. Do it wrong now, that's not wire tech. Make a mistake. That is O4. All right, that is O4. Sorry. This is O4. So I can't undo it. Let me see. Let me just write OF. Let's write over this OF. This is O4. 75 degrees was O4. My mistake. All right. It don't really matter. O4. All right. The next one we're going to put in is for the wire tech, which is 150. 150 is measured from that line. So bring back the protractor and you have to rotate the baseline around to this one now. So that, if you rotate it around to that second line, and measure 150 now from that line, 150 from that line now. And reading the zero scale again. Do not read the scale that is counting down. Read the scale that is counting up. So 150 is going to take us all the way around. Make this take a smaller. All the way around to here. See here, 150 and 0 is the inner scale. All the way around to here. Down here, so. See it? We have put in the mark now. That's the line that also passes through 30. I'm going to put a little dot there. That is my little dot. So then I draw the line out to here. I'll come out to this place, but I'm going to just stop it right there, so. That is 150 degrees in here now. And this is now O4. No, wire tech. It's for wire tech. See here? Wire tech is 150. So this is a WT now. Wire tech. The next one is digit. No, next one I have is other, which is 45 degrees. I'm going to measure 45 degrees from that line. So you go back for it again. And you rotate again. You want to 0 to this line now. See? 0. It's down the point, rotate it around to 0. What we can just do the 90 degrees for the digit leg. And the rest of it will be 45. So we can do the 90 degrees for digit leg, which is going to be right up here. I'm going to put a dot right there for the 90. That's it. And move it. And draw a line out to there. There's a line out to here. That will be 90. And the 90 is for digit leg, right? DL. And the angle is 90 degrees in here. Then the remaining piece is 45 degrees, and you can measure it. And 45 degrees was other, O for other. That is the pie chart. All right. What else I want us to do in this question? So we draw the pie chart. Let's continue. All right. Our part B now. Part B says, so part B is a different question. Let's just finish it. Part B says, the incomplete table below shows the results obtained by 200 boys and 250 girls in a Spanish exam. It says a girl is chosen at random. So we're taking from the girls. And there are 250 girls. They're not giving us these results. Right? But we know that total is 250. So all of this from 250 give you the total in this group. Right? But let's read. It says a girl is chosen at random. Determine the probability that she achieved a grade 1. So it's basically 62 out of the 250. Those are the girls. See that? Because we're talking about the girls. A girl is chosen at random. What's the probability that she got a grade 1? 62 out of the 250 girls. That is it. So that is 62 out of 250. And you write that in lowest term. That's what the character gives us. That's 31 out of 125. Let's see. The lowest it can go. 62 out of 250 in lowest terms. Yeah, 31 over 125. I was correct. 31 out of 125. All right, that finishes the first part. The next part says, what percentage of the boys who took the exam got grade 1 to 3? What percentage of the boys who took the exam got from grade 1 to 3? Let's look at the boys now. So first, the grade 1 to 3 was not shown, right? So the number that got grade 1 is 200 minus this 38 years. Agreed? From 1 to 3 is 200 minus 38. That gives you the total boys from 1 to 3, grade 1 to 3. So it's 200 minus 38 at 162. So 162 boys inside here. 162. Total for these 3, up here to here, is 162. They don't show them individually, but it's 162. And I want as a percentage, and the boys were 200 boys. So it's 162 out of 200, that's like 81%. So this is 162 out of 200 as a percentage, you multiply by 100, and get as a percentage, that's going to be 82. I divide this into this to get 2 times 81. 2 into this goes 81. 81%. So 81% pass. But go to that. But with that in another class, you know.
Yes, sir.
Another class, you know. 99% get grade 1, you know. But the foolishness, you know. P grade 1, you know. Anyway, let's continue. Next part says, the first one I finish it. Ready now. This part says, we want the 1 mark, you know. 1 mark for it, we want it. We want every mark on the exam paper. Consider the standard deviation in the table on page 18. Now listen, they ask you from time to time. I think I've seen maybe 3 or 4 times already. They ask us to compare standard deviation, and the comparison is simple and the same every time. The one with the higher standard deviation means that the data varies more widely from the mean as compared to the one with the lower standard deviation. So the one with the higher standard deviation, you're going to say varies more widely. The one with the smaller standard deviation varies more closely spread from the mean grade. Keyword, you have to say from the mean grade, from the mean grade. Standard deviation is measuring spread from the mean grade, from the mean grade. If you don't say from the mean grade, you might not get the 1 mark. So this one says, consider the standard deviation in the table. Compare the performance of the boys and the girls. So see it here now. Standard deviation you're comparing are these 2 values. This is the larger one, this is the smaller one. So see it here. This one is a larger value, right? Let's put it here so we can have an understanding. The larger value, more widely spread from the mean grade. The larger one, more widely spread. That's what key thing you have to say for the larger one. More widely spread. The grades are more widely spread from the mean grade of the boys. More widely spread is a measure of spread, measure of deviation, more widely spread from the mean grade. And that is as compared to the girls. That's what it is. So the grades of the boys are more widely spread from the boys' mean grade as compared to the girls. And if you're referencing it from the girls, because this is a lower value, but this one is a higher value, that's why you're going to use more widely spread. This one is now more closely spread because a lower value. So the grades are closer to one another because that's a lower standard deviation. If it's a lower standard deviation, means that the grades of the girls don't spread out so much from the mean grade. The grades of the girls are closer to one another and closer to the mean grade. So you're going to say more closely spread, and it is in comparison to the boys. You're comparing the 2. So you have to also say in comparison to the grades of the boys. So this one is now more closely spread. So use that term like more closely spread. Because it is less, it is more closely spread. more closely spread from the mean grade of the girls as compared to the grades of the boys. You understand me? As compared to you're comparing. So you have to say in comparison to the boys. So let's write it now. I'm just putting this on the paper just to indicate to you. When the standard deviation is higher, the larger one, we can say more widely spread. When it is a lower standard deviation, more closely spread. And you have to say from the mean grade. You see? From the mean grade. See there, from the mean grade. You have to say from the mean grade. Here I'm going to say of the boys. Of the boys. But this one was for the boys. So the boys have a higher standard deviation. So that the boys, the grades of the boys vary more from one another as compared to the grades of the girls. The grades of the girls kind of closer to one another and closer to the mean grade in particular. Standard deviation is a measure of deviation from the mean grade. That's what standard deviation is. All right, so we're going to write something now. So we're going to reference it from the boys first. And so you write. You don't need to write both of them, just you need to write one. All right, so we're going to say the grades of the boys. Let's write it out now. If I were to write the next, I'll write something like this. The grades of.
Excuse me, sir.
Yes.
Did you do vectors and matrices?
I did vectors and matrices and transformation and bearings and all those topics 2 weeks ago. So there's a video on the channel with it. Today we're just basically doing questions. So if you have a question you want me to do from a past paper, you can let me know and I'll go to it and do it. All right. Just find a question that you want me to do. That's what we're doing today. We're not really teaching from scratch today. We're just doing questions and doing as much explanation as we can without actually teaching from scratch. All right. So the grades of the boys, we're referencing the boys, right? The grades of the boys. The boys are the higher value, right? The boys are the higher value. Yes, the boys had a higher standard deviation, so they are more widely spread. The grades of the boys are more widely spread from their mean grade. As compared to the grades of the girls. Or you could write it from a reference for the boys. Or you could write it this way, if you're referencing the girls, I mean. Or you could say, the grades of the girls, referencing the girls now. But the girls have a lower standard deviation. They are more closely spread. We still have to say from there, talking about the girls. Mean grade. As compared to the grades of the boys. That's it. Want the one mark, write the right thing. Key things to say to get the right answer, to get the mark. More widely spread or more closely spread. And the second important thing to say is from the mean grade. You have to make sure say, oh, you write that sentence, that is line is in there. From the mean grade. Standard deviation is a measure of spread from the mean. From the mean. From the mean. All right, so you have to say from the mean. If you don't put in that phrase, chances are you won't get your mark. All right. All right, so which question somebody want me to do? Done with this paper now? 2019? No, we're doing her paper on this paper. The vectors on this paper. All right. All right, the vectors on this paper. The vectors on this paper. Just the vectors alone? All right, don't you, sir? I want baby vectors this, you know. The vectors don't have no sugar on it at all. Zero sugar on this vector. Zero. All right, let's do it. This question, this vectors don't have nothing on it, man. Straightforward. All right, let's go. It says ABC is a parallelogram. It's a parallelogram. So right off the bat, you know the opposite sides are equal vectors. Why? Because the opposite sides are parallel and equal in length. So they are equal vectors. It says X is the midpoint of AB and Y is the midpoint of BC. OA is the vector R and OC is the vector S. Complete the diagram below to represent all information given above. All right, watch this now. So they have started, the parallelogram is OABC, and they have started O and A right here for you. You absolutely cannot go and put B down here, sir. Wrong. You have to maintain orientation. You get me? So since they start with an anticlockwise orientation, O to A, B has to be here, and C has to be here. The orientation cannot, you can't go crisscross on a diagram. Or you label a diagram is one orientation. Clockwise or anti-clockwise, that is standard. You label it in alphabetical order, and you label it in one consistent order, in one consistent orientation. That's the first thing. You can't go and put B down here, so. You can have AB and OA, sorry. Remember, I know it's OABC, you know. So it has to be in that same sequence in terms of the orientation. So you can't put B here. You can't have OAB and then come back this way to put C. That's the first thing. So the B has to be up here. Everything important. Everything is important. So the B must be here and the C must be here. If somebody put C down at the bottom, them just dead. If somebody put B down there so and C there so, them just dead. All right. So you have to put B right here and C right here. All right, that's the first thing. Everything important. The next thing says X is the midpoint of AB. So AB here. So X is here. Now remember, if you put the B down, I say no, then this would have be AB. You get me? Into the wrong. All right. So if I put it the right place. So X is right up here, so right? X is right here. So that's the point X. And Y is the midpoint of BC. So BC here, so Y is the midpoint of BC. So we'll put in Y right here. So X and Y divides those two lines half and half, right? Let's put in the vectors now. Let's put them on in red. And let's break them up where we need to. So they tell us that the vector OA is R. That's this line. This vector up here is R. So this vector right here is the vector R going from O to A. And so this side over here so it's also R. So what is now? All of this is R, you know. But the Y divides is half and half. So it means that we can divide the vector also half and half. So from here to here is half of R. And from here to here is another half of R. And a similar thing happening on this side up here because they tell us that OC down here so is a vector S. So down here is OC, it is a vector S. So the whole of this vector from A to B is also S, but then X divides it half and half. So it means that the vector from A to X is half S. And the vector X to B right here is another half S. So we kind of break down the diagram as much as we can, as much as we need to. So, we can see how we go from point to point. But that's what vectors is at this level, Just seeing how you go from point to point. They're like roads. The vectors are like roads that will take you between the points. All right? And you want to go in the same direction as the vector. If you go in the opposite direction to a vector, then you have to introduce the negative sign. All right? All right. Question says now, given that OX plus OY is K times R plus S, where K is a constant, use a vectors method to find the value of K. Now, if I'm going to find the value of K, all I need to do is work out what OX plus OY is, set it out in this format, and then see what the K is. You get me? That's all I need to do. Work out what OX plus OY is and write it to look like this. And then I will see what the K value is. That's the best way to do it. You get me? Work out what OX plus OY is actually in terms of the R and the S. And you see what the K is after you factorize. So let's go. All right. So we need to work out this OX plus OY. So we look at the diagram and see what OX and what OY is. All right. So OX plus OY becomes equal to, now what is the OX? Let's look at the diagram. How do we go from O to X? Easy. Vector shows us we're going to come up here with an R and then go here so with a half R, don't it? Easy like that. Half S, sorry. R plus half S. So that is R plus half S. That takes us from O to X. This is the first part. Plus, how do we go from O to Y? From O to Y. Again, I'm going to come across here so with the S and then go half R right here. See that? Simple. That becomes S plus half R. So this becomes S plus half of R. The answer is 1.5. And see it already. Then if you consolidate the values, these are the R values first. I'm going to consolidate the values. R and a half R, give me 1.5 R. If I add these two, add up everything. That's 1.5 R, right? 1.5 is the same as 3 over 2. So that's 3 over 2 R. That's 3 over 2 R. So it's 3 over 2 R. Then add up the S now. Half S plus S. That's half S plus S. Again, that's 1.5 S. 1.5 is still 3 over 2 S. So this becomes plus 3 over 2 S. Then I need to just factorize this 3 over 2 from those two. And I get 3 over 2 bracket R plus S. So if you compare it now with this thing that they gave us, sorry about that. Compare it with this thing, this is K into R plus S that they gave us. Comparing, right? Compare. You see that the K equals 3 over 2. Or 1.5. Right? So if you compare, K equals 3 over 2. That's the answer. This question too easy. All right, so we're done with this paper now? Yeah? All right, so 2018, that's right? 2018. Online, everybody finish with this paper for move on?
Yes, sir.
All right, 2018. Which one of 2018 January? Which January? All right, January 28th.
So is there a chance they will bring a question from maths paper 3 or something similar to maths paper 3?
You can bring anything from anywhere on the syllabus, you know. But the questions on the paper 3 are usually questions that are set up to be sort of real life situation, SBA like. They're not doing an SBA, doing a paper 3. So they tend to put questions that are real life. But then a lot of the questions on paper 2 are like real life as well. So this is possible. But if you just look at the last 10 years past paper 2s, then you'll see the type of question that they tend to set. You don't need to go past the last 10 years to see the structure of the questions. Yeah. Where are we now? See, set past papers. This is January 2018. Now we're going to take a break. And how long now we're going? Have some more stuff around there. Huh? 1 2 hours already? So time fly, man. All right, when is this? I'm going to take a short break. All right. All right. Which question you want on this now? Question 5, part B. All right. Question 5B. All right. Question 5B. All right. So in order for you to do question 5B, question 5B relates to 5A. So for the 5A first. All right. So let's look at 5A first. And since you don't really want, we can run through it fast, right? You really want 5B. All right. So 5A says a regular polygon, very important word, regular. Regular means all sides equal, all angles equal on a polygon when it is regular. A regular polygon, EFGHIJ, shown below, has a center O. Triangle OEF is equilateral. This triangle is equilateral, which means that since this side is 5, means that this side is also 5, and this side is also 5. Also, because it is equilateral, the angles inside the triangle each equal 60 degrees. So this angle is 60 degrees, and this angle is 60 degrees, and this angle is 60 degrees. Because it is equilateral, this triangle. All right? And that is expected because it is regular. Regular means usually mean everything nice and symmetrical. All right. It says, what is the name of this polygon? The name of it is based on the number of sides that it has. The name of a polygon is based on the number of sides that it has. So this has 1, 2, 3, 4, 5, 6. A 6-sided polygon is called an hexagon, right? Like that. Hexagon. A 6-sided polygon is a hexagon. Good. Next one says calculate the perimeter. One mark for that in it. It has 6 sides and it's regular. Since it's regular, it means that all the sides are the same, right? So all the sides of them are, all sides is 5 and there are 6 of them. So the perimeter is, let's call it P for perimeter, is 6 times 5 centimeters, which is 30 centimeters. The distance around it is 30 centimeters. 3 marks. Let's go. Next part says determine the size of the interior angle of the polygon. I want to show you a way to do this. Separate apart from the diagram. Now, the diagram shows you that is 120. Now, let me show you why. It's because it's regular. If I put another triangle here, and the angle is really asked, question is really asked the angle between the sides here, so right? That's what it wants. Which basically will also be this angle right here, so right? That's what it wants, the angle between the sides. But this angle is 60 degrees. Now, if I were to draw another one here, then this triangle and this triangle is exactly the same, you know? So it would therefore mean that this angle is also 60. That's all. And so the total angle across here would have been 60 plus 60, which is 120. Cool? All right, so let's say they didn't tell us that. but it's regular and it's a hexagon. And we're not doing it that way. We could have said, okay, it has 6 sides and so it has 6 angles, right? That's all. So we could calculate the size of each one since it's regular by calculating the total and dividing it. And all right, let's do it another way. Take that picture and show you something. All right, showing a nice way to do it. Total exterior angle of any polygon is 360 degrees. The total exterior angle of any polygon is 360 degrees. No matter how much side it have. It have 1 million sides. It have 1 million sides. And Archimedes used a polygon of 96 sides to calculate the value of pi. 96 sides. And it was a regular polygon with 96 sides. The total exterior angle is still 360 degrees. No matter how many sides it has. This one has 6 sides. So each exterior angle is 360 divided by 6. An interior angle plus an exterior angle add up to 180 degrees. So if you know the exterior angle, you just subtract from 180, you get the interior angle. You understand what I'm saying? Let me sketch it and show you what I'm talking about. I'm just using this opportunity to show you this thing, right? So we have this. Let me draw it in blue. I'm just going to draw it and then copy it down. I'll show you something that is useful. All right, watch this now. I'm just showing you something down here. Now this is a polygon, right? An exterior angle is this. If I take one side and extend it and make the angle with the adjacent side to it, that's an exterior angle. It has the number of sides, the number of angles, number of vertices will always be the same. So since this has 6 sides, it has 6 interior angles, 6 exterior angles, 6 vertices, and so on. So it has 6 equal exterior angles, and all of them equal, and the total exterior angle is 360. So it means that each exterior angle is 360 divided by 6, don't it? So see it here, it has 6, polygon has, and the hexagon has 6 exterior angles. And the total of those 6 exterior angles is 360 degrees. And because it's regular, all of them equal, don't it? So therefore, each exterior angle equals the total of 360 divided by 6. So each exterior angle is 60 degrees, don't it? So the red angle out there so is 60 degrees. Each of them is 60 degrees. This out here so is 60 degrees. The interior angle to that 60 degree is this one that I'm going to now mark in purple, right here, which is what the question is asking us for. Can you see that the interior angle and the exterior angle up to 180? So once you know the exterior angle, once you know the exterior angle, it goes to 180 minus the exterior angle, you get the interior angle. See that? So this interior angle right here becomes 180 degrees minus the exterior angle that we calculated. So each interior angle is 120 degrees. So that's a nice way to do it. So see there? The total size of each interior angle, see the 120. So each interior angle is 120 degrees. Just decide to show it that way. But you could have gotten it from the diagram up here, right? 60 plus 60 across here. So see that? Good. All right. It's 120. Our next part now says, show by calculation that the area of the polygon to the nearest whole number is this. So basically then, to get the area of the polygon, we can calculate the area of one of the triangles, this one, and multiply it by 6. Because there are 6 of those same triangles in it, right? And what we can use to get the area of the triangle is, we can use a formula that says half AB sine C. So we could draw the triangle like this. Angle in here is 60 degrees. This side is 5 centimeters. This side is 5 centimeters. So the area of that one triangle becomes half, using half AB sine C to do it. 2 sides and the angle between. So it will become half 5 times 5 times the sine of 60 degrees. That's going to give you the area of one of the triangles. And there are 6 of them, right? All right, let's copy this down now. So calculate the area, total area. All right, so the area that they want, I'm going to call it capital A. All right, the area that they want is 6 times the area of one of the triangles, right? Which becomes 6 times half 5 times the 5 and the sine of the 60 degrees. That's not the only way to do it, but good enough. And when you work this out with the calculator, you're going to get what they said. So this becomes, this is really 3, half of 6 is 3. It's really 25. So you get 3 times 25 times the sine of 60. Sine of 60 is root 3 over 2 or 0.866. Let's put it on the calculator. So we get the 64.9. See, they tell us that's approximately 65. We get the 64.9. So we're going to say approximately 65 centimeters squared, sure. All right, so that is the area of that hexagon, right? Cross-section area 65. All right, so we're going to need that for the next part of the question. Next part down here now says, a tank has a cross-section with the dimensions identical to the polygon in 5A. So this cross-section is the same polygon that we just calculated 65 area for, right? So we know already that this is an object with uniform cross-section. The formula that governs this object for volume in particular is that volume equals cross-sectional area times the length, right? But we already know that the cross-sectional area is 65, so we can write that. Cross-sectional area, the A, is equal to 65 centimeters squared. We just calculated it a while ago. That is the cross-sectional area of this thing. All right, 65 centimeters squared. So we have that. And we know the volume will be equal to the cross-sectional area times the length. The length is this, or the height right now is the height. The length is the distance between the two ends, the bottom end and the top end. Anyway, it said determine the capacity of the tank. Oh, they tell us some additional information. Sorry about that. It says water is poured at a rate of 75 centimeters cube per second. It says after 52 seconds, the tank is 2/5 full. And I want us to calculate the capacity. The capacity is the full volume. That's what the capacity is. The full volume. And I've given us some information about what takes it to 2/5 of that full volume. So if they're pouring it at 75 centimeters per second, you say every second and put 75 in there. And you want to know how much is in there after 52 seconds. After 52 seconds, it is 2/5 full. So we can set this up like this now. So 2/5 full, 2/5 times the full volume is equal to 52 times 75 centimeters cube. Understand that? Understand that? What I don't understand. Which part I don't understand? I just wrote what they said. You put in it at 75 cm cube per second. All that means, you know, at every second you put 75 cm cube in it. You must go in after 2 seconds, 150. After 3 seconds, 3 times 75. After 4 seconds, 4 times 75. After 5 seconds, 5 times 75. After 52 seconds, how much gone in there? 52 times 75, don't it? Every second you put in 75. So after 52 seconds, the amount that has gone into the tank is 52 times 75 cm cube. You understand that first? That's a volume in the tank. And they said that volume represents 2/5 full. That's why they said 2/5 full. It is 2/5 full. So 2/5 full is 52 seconds times 75. That's all I've done here. 2/5 of the full volume is 52 seconds times this 75 per second. Full? And what are we trying to calculate? We're trying to calculate the full volume. That's what the capacity is. So we can calculate it from this. Just transpose this 2/5 over here. So the full volume, which is the capacity, becomes multiply up the 5 and divide under the 2. So it's going to become 5 times 52 times 75 cm cube over this 2 come under here, so now you divide the 2. Work that out and get your full volume. Nice and easy. See that? Simple as that. Now, if you wanted to work out this volume first, fine, but I like to do the maths now. We use the calculator one time. Right? So you're not learning nothing. So you're not learning nothing. One soji in here. One me know about. One me know about. One. Only one I know about. They say, I agree, say, not learn nothing. So 9750 is a full volume. 9750 cm cube is a full volume, but I want it in liters, see? For the instructions. So 1000 cm cube make a liter. So we divide this now by 1000 to get it in liters. Eh? So this then becomes, move the decimal point 3 places to the left there to get it in liters. So it becomes 9.75 liters. That is the full volume in liters. All right? Have another part to it? Okay. Let's now calculate the height of the tank. So now that we know the full volume, I know the cross-sectional area, we can use that relationship, right? Because we know that volume equals cross-sectional area times the height. And we want the height. So you divide by the area to get the height. So it means then that the height that we want is the volume of the tank over the cross-sectional area. And we have both of them. So remember, we have to work in cm cube. I want the height in centimeters, right? Can't work in liters. So therefore means that the height, this height, comes equal to this volume, which is 9750 cm cube over the area, which was 65. Cross-sectional area was 65. That's going to give us the height in centimeters. So 9750 divided by 65. That's 150 centimeters, right? All I want it in meters, see? For the instructions. So this is centimeters right now, you know. To get it in meter, we divide by 100. 100 centimeters. Remember, centi means 100 parts. When somebody make a century, 100 runs. Centi. All of those words kind of connected. A century is 100 years, don't it? Right, 100. So 100 centimeters make a meter. Can't forget it. So this therefore is 1.5 meters. 1.5 meters. And that is it. Any other question from this paper? We're going to break after this. Anybody online want a question from this paper? Anybody want any other question? One question after the break? All right, online. Gather your questions, you know. We can't take them dead zone here, you know. Decide which questions you want so we can be working. Want to take a 15 minutes break? Or let's take a 20 minutes break? Let's make a note of the question that you want me to do when I come back. We're going to take a 20 minutes break. We're going to put the timer on the clock. We're going to take a 20 minutes break. We have some more stuff around there from yesterday, yeah? Let's put up the timer.
So question 4.
Question 4 on this paper?
Yes.
Hold on a second. All right, so we start back with this number after the break here. We're taking a short break now, okay? So we start back in about 20 minutes with this question. We're just gonna take a short break. All right, put the time. All right, we're back. Online, ready for us again? Hello, are you there?
Yes, sir. Yes, sir.
All right, so somebody wanted us to start back with this question. So let's do that. It's 2028, January 2018, number 4. It's a coordinate geometry question. All right. It says the equation of a straight line L is given as this. And hey, we start back here. We have started. And it says we have to write the equation of the line L in the form y equals mx plus c. So it's basically to take this and write it in this format. Make y the subject. All right. So multiple ways to do it. What I'm gonna do is transfer the 4y over this side to make it positive, and transfer the 5 on this side as the first transposition. So I'm gonna have 3x minus 5 equals 4y. And then to get this 4, I need to divide 2 by 4. So I divide this by 4, divide this by 4, divide this by 4. So divide each term by 4. Divide through. Hey, I've started. Divide through by 4. I'm gonna get 3 over 4x minus 5 over 4 equals y. And it's a matter of just turning this equation around now and say that it is y equals 3 over 4x minus 5 over 4. That's not the only way to do it, but that's good enough. All right. Next part wants to determine the gradient. So when it is in this form, the gradient is the coefficient of the x. That is the m. So we can just write it down. The gradient m is 3 over 4. That's the gradient of line L. All right. Next part says a point P has these coordinates, lie on the line, determine the value of r. This is it. So it means that this point can be substituted into the line equation, but I'm not going to use that one because I'm trying to find an x value. So I'm not going to substitute it in that one. I'm going to substitute it in the original equation that was given up here. Because r really is an x value. So I'm going to substitute it in that one. All right, so I'm going to substitute it in the equation 3x plus, what was that? 4y, is that plus 4? No, minus 4y plus 5. 3x minus 4y equals 5. And since this point is on the line, then it means that the coordinates satisfy the equation of the line. And so substituting these values in that equation. Let's write that in red. Substituting these x and y values in the equation. When we do that, we're going to get 3 times r, because the x value is r, minus 4 times 2, because the y value here is 2. So it's 4 times 2 equals 5. And this becomes a negative 8. Negative 8 goes on that side and become a positive 8. So the r becomes 5 plus 8. And take this 13 and divide it under. 5 plus 3, sorry, and divide it under. So it becomes 5 plus 8 over 3. That becomes 13 over 3. That's the value of r, 13 over 3. All right. Next part down here says, find the equation of a straight line which passes through this point and is perpendicular to L. Let's call that line, line 2. Let's call this line that we want, line 2. Straight line, I'm going to call it line 2, so we can reference it. Or L2. So that line is perpendicular to L1. So it means that the gradient of line 2 that we want is -1 over the grade of the first line. Grade of the first line is this 3 over 4. We just need to flip this 3 over 4 and change the sign to do this calculation. That's a quick way to do it. Or you can take it and put it under here for the ML. But the quick way to do it is just flip this gradient that we have and change the sign. Hello. Relax now. I'm giving you a minute, taking too long. This becomes equal to -4 over 3. -4 over 3 is then the gradient of the second line that we want. I would say to pass through this point. Let's call this point Q, so we can reference it. Let's call it Q. And it passes to the point Q60. So then we get an equation using this gradient and this point. So that equation that we want is y minus the y value at that point Q equals the gradient of the second line that we're trying to find into x minus the x value at that same point Q. Plug in the values now. Y minus the y value at the point is 0 equals the gradient is -4 over 3 here into x minus the x value at the point here is 6. And we'll simplify this. So this side just simply becomes y equals, this becomes -4 over 3x. We're multiplying this -4 over 3 by this 6. First, the negatives cancel and give me a plus. Then the 3 into the 6, or 6 divided by the 3 is 2. And 2 times 4 is 8. So I'm adding 8. And that is it. That's the equation of that second line. The next part. Want this part as well? Want part B as well? First online. Or did you say just A? Hello?
Yes, sir.
You want part B as well? That's what you're saying, yes?
Yes, sir.
All right, good, no problem. All right, let's do this. So I don't need this for that part. All right, so this is linear inequalities to be represented on a graph. You ready? Not quite now. All right. All right, this one first, it says we have to draw these lines. X plus y equals 10 and y equals x. Those are like the easiest lines to draw. X plus y equals 10 is what we did earlier. Crosses the y-axis at 10 up here and crosses the x-axis at 10. X plus y equals 10. All right, so we need that line. So it passes through points where the x and the y value add to 10. So it will therefore, for example, pass through 5, 5. So it's going to pass right down the middle of the graph like this. Right down this graph. Right down to this point and to those points, right? So I have to draw it with my free hand and over a ruler on this device. That is it. Label the line with the equal sign. X plus y equals 10 is the equation of that line. Then we need the line y equals x. That's the line that passes through points where the x and the y value is the same. Y equals x. The x and the y value is the same. So it passes through 0, 0. It will also pass through this 5, 5. It will also pass through this -5, -5. I've seen persons doing this question in the past, and to draw the line y equals x, then just draw a random line up like that. Just draw a random line up like that. You cannot do that on a graph. It's not a sketch, it's a drawing. You have to draw it through the correct points. All right? So the reason why I'm drawing with my friend because I can't use a ruler. Straight line feature on this device, right? So I have to draw it with my friend, but you need to draw it with your ruler. So the line y equals x will pass through 0, 0, and will pass through 5, 5, and will pass through 10, 10. I will pass through -5, -5, and -10, -10. All those points. So I'm just going to draw a straight line now. Like that. You do it with your ruler. Don't draw it freehanded like me. Draw it with your ruler. y equals x is the equation of that line. So I've drawn the two lines that they wanted. X plus y equals 10 and y equals x. Next part now says, on the grid, shade the region which satisfies the four inequalities, these four inequalities. All right, let's go step by step. Now remember, inequality on a graph is represented by a region that is either above a line or below a line. The line can also be included if the equal is on the inequality. In all these cases, the equal is on the inequality in each one. And so the line is a part of the region that you want. You want the line and the region either above or below, depending on the inequality. So this one says you want the region for x greater than 0. How do we read this? This really means, you see, you want where x values are greater than 0. So you want where x values like 1 and 2 and 3 and 4 and so on, right? So this region starts at the line x equals 0. So the line associated with this inequality is the line x equals 0. Line x equals 0 is really the y-axis. And the greater than 0 means that you want values above. Above usually goes with the greater than sign. So this would say above a solid line. These are all solid lines because the equal is on all of them. So I'm going to write all solid right here. All solid lines. If it was not equal, and for example, this was just a greater than sign alone without the equal, you would have to draw a broken line because it means that you would not want the line. But once the equal is there, it means that you draw the line solid. So I'm going to write all solid lines. So for this one still, I'm doing above which line? The line associated with this inequality is the line x equals 0. X equals 0 is actually your y-axis, which is a vertical line. So I might say, okay, how come you're saying above? This is the y-axis. This y-axis is the line x equals 0. This inequality is referring to the fact that you want values over here to the right of that y-axis. On a vertical line, above means to the right, below means to the left of a vertical line. Above means to the right, below means to the left. So I'm going to the right of this vertical line, x equals 0. So I'm just putting arrows to show where my region is going to be. It's going to be to the right of the y-axis. This one is a similar thing. Again, I'm going above the line. Whatever is positive, greater than means above. So I'm going above the line. Which line? The line associated with this inequality, which is y equals 0. And y equals 0 is just the x-axis. So I want to go above the x-axis. See, the x-axis is the line y equals 0. This x-axis right here. I want the region above it, up here. So far, I want in this quadrant, above this horizontal line and above this vertical line. Above a vertical line, remember, it's to the right. All right, that's the region I want so far. So I'm putting an arrow pointing up on the x-axis to show that I want above the x-axis. All right. Then this over here, this inequality now. When you read that inequality and the y value on the left side is positive, less than means you want below the line. Simple as that. If the y value on the left side of the inequality is positive, less than means you want below the line. Greater than means you want above the line. We're not gonna go into any deeper explanation of why that is so, but that is so. You need the y value on the left side of the inequality to be positive, for greater than to mean above, less than to mean below. Anything apart from that, greater than don't mean above anymore, less than don't mean below anymore. So in this case, the y value on the left side of the inequality is positive. See, it's a positive y. This less than sign means that I want below the line associated with this inequality. So I want below the line Which line? The line associated with this inequality is x plus y equals 10. Just change this inequality sign to an equal and get the line. X plus y equals 10. So I want to go below that line. This is the line x plus y equals 10. See here, we drew it earlier. I want to go below that line. So I'm going to put an arrow pointing down on this line. And down here I can put it as well. So I want the region below that line. So far, the region that I would want would be inside here for those three that I've done so far. But I have one more inequality to put in, right? So I'm narrowing down the region that I want. So far, that's the region that we want. To the right of the y-axis, above the x-axis, and below the line x plus y equals 10. But we have one more inequality to put in. I have to be careful with this one now. Because they have gone and take this inequality and put the y on the right side. Right? They put the y on the right side. And then we have a greater than sign. And plenty of people are going to know that this relates to the line y equals x that we have now. But the y right now is on the right side. So that greater than sign you're looking at right now, it does not mean above. Because the y is on the right side. The y needs to be positive on the left side to mean above. For greater than to mean above, and for less than to mean below. So I'm going to read this inequality and just turn it around so that the y is on the left side. So this inequality can be read from left to right or from right to left. So you can read it the other direction and write it instead. Write this inequality instead as y less than or equal to x. It's the same thing if I read it the other way. X greater than or equal to y is the same as saying y less than or equal to x. Know that the y is on the left side and positive, I really have a below situation because I really have a less than. So I really want below the line, not above. So if I read it using this, then I'm going to say that I really want below the line y equals x, which is the line that we had. So it's the line y equals x here. I want the region below it. So if you look at it, the region that I want is below this line, and above this line. So the region that we are to shade is inside here. Satisfies all the inequalities. That's the region that I want. Understand that? But you understand that? Online,
Yes,
understand
sir.
that? All
Yes,
right,
sir.
good. Beautiful. All right, so that finishes that question. All right, so that finishes this paper. Who else want a question now? Who else wanted a question? You have a question that you want? No? Want to go home? You have a question? Huh? 2022, question 6. 2022, question 6. 2022, question 6. All right, number 6. 2022, number 6.
And the question 10 in this paper as well.
Question 10. All right, this question. All right, no problem. All right. So this question is a question about an object with uniform cross section. Call it a prism. There are 3 formulae that can be used to govern calculations related to these objects. 3 formulae. You remember those 3 formulae, you're good to go. It made the calculation very, very easy. And these are the 3 formulae. I'm writing more touch up here. The first one is that the volume is equal to the cross-sectional area times the length. The A is for the cross-sectional area, the L is for the length. That's the first one. The volume of the object with uniform cross-section is the cross-sectional area times the length. The cross-sectional area is also the area of the ends. So the area of the end here, the two ends are the same. And the end is a cross section. The end has the same dimensions as the cross section. So the end area and the cross section area are the same thing. So if you calculate the area of the end of the object, you have to calculate the cross sectional area. That is the A. The L in this formula refers to the distance between the two ends, whether it is vertical or horizontal. If it's vertical, they usually call the L the height, H, if it's vertical. But if it's horizontal like this, they call it L. But it's the same thing. The distance between two cross-sectional ends is your L. So in this question, this will be your L. That is your L. As the first formula, volume equal to cross-sectional area times the length when you have an object with uniform cross-section like prisms. The second formula to know is the formula for the curved surface area. CSA means curved surface area. CSA. Then come in. If you're not going to talk, I better not go outside. Not disturb me. Curved surface area is equal to the perimeter of the end multiplied by the length. It's a very powerful formula, that one. That gives you the area of the faces around the side of the object. Curve don't only mean curve. Even if the sides are square, any shape, it's still called curved surface area. The curved surface area does not include the ends. So the surface area excluding the ends is called a curved surface area. What some people do, they add up this area of each piece. So we'll add up the area, for example, of this piece, the piece at the background there, the piece at the front, and then the curved area on this cylindrical part. You don't need to do that when it's an object with uniform cross section. Just need to find the perimeter of the end and multiply it by the length. I demonstrated that in the class one day with a flat piece of paper when I roll it up into a cylinder and open it out back. If you open it out, it becomes a rectangle. So the perimeter of the end becomes one side of a rectangle. So it's like length times width when you roll it out. I demonstrated in the class. So tomorrow's exam, I don't have time to do that now. That gives you the area of the area around the side. Curved sides or flat sides add up together. All right. Then we have the total surface area. Come time question we ask for the total surface area. That now is a curved surface area plus the two end areas. Some object might have one end open, like an open-ended cylinder, for example, one end open. So then it will be the curved surface area plus one end. But most times with the prisms, the solids, two ends are solid. So the two ends are also surfaces. So then it becomes, total surface area becomes the curved surface area that we have here plus 2 times the end area. 2 times the end area is one for here and the other one for there. And then the curved surface area now is around the side of the object. All right. Remember that this CSA is just equal to the perimeter of the end times the length. So we can instead write this one as the perimeter of the end times the length plus 2 times the end area. Them three formula there govern everything relating to the calculation of these prisms, object with uniform cross section. It made the calculation easy for these. A lot of people tend to be adding up sides and pieces and all that. They don't need to do that. All right, I'm going to show you now how we can use that in this question. All right, for total surface area. All right, so let's go. It says, the diagram below shows a solid made of a semicircular cylindrical base. You don't know, so a semicircular cylindrical base right here. That's the bottom piece right here, right? And base with a rectangular prism above it. So this is a rectangular prism on top of it here. All right, a rectangular prism. It says the diameter of the cylindrical base and the width of the rectangular prism is 4 centimeters each. We don't do circular measures with diameter. We tend to do circular measures with radius. Like area is pi r squared and circumference is 2 pi r. The first thing I'm going to do with this diameter that they gave us is write that the radius is really 2 centimeters. I'm write it here. The radius is really 2 centimeters. I'm going to be working with the 2. R equals 2. Put it here, so R equals 2 centimeters. Don't want to forget. So that's the radius. That gave us 4. The radius is 2. First part wants us to calculate straight away the total surface area of the solid. So it's asking us for this right here, so. So we need the curved surface area, which is perimeter of the end times the length, and we need the 2 end areas. All right? You don't need to go piece, 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 piece. And they gave us this little assistance down here, which to me is not really an assistance. Because they're telling us about the area of a cylinder when it's a half a cylinder they gave us. All right? I don't think we're bothered with that. Ignore that. So let's go. All right. So the first thing we're going to do for this question, we're going to calculate the end area, A. Because we need the end area right here. So to calculate the total, to calculate the total surface area, we need the end area. So I'm going to calculate the area of the end here. So first, the end area. What is the end area? The end area or the cross-sectional area is the area of this rectangle. It's actually a square because this is 4 and this is 4. So right here says 4 too. It's uniform enough. All right? It's uniform. So it means that this is a 4 times 4. So if we put on the dimensions on this, then right here says 4 as well. Let's put on all of that. Right here says 4 centimeters as well. And over this side is also 4 centimeters, right? That's this side is 4, this side is 4, this side is 4. This is also 4, but that goes across the shape, so I'm not going to worry about that. Then down here now we have a half a circle. We have half of a circle. You have a circle, it's pi r squared, that's half of a circle. So it's half of pi r squared. So to get the total area of the end area is going to be the area of the half a circle plus the area of the square at the top. So let's write it out here. What space they give us? See? They don't even give us a lot of space to work with. But no problem. So I'm going to call it end area first. Cross-sectional area, end area. So I'm going to just call it end area. A is going to be equal to the rectangle of the area of the rectangle at the top is actually a square. You have the square at the top plus area of the semicircle, S circle. Let's call it S circle. That gives you the area of the cross section. Area of the square is 4 times 4, don't it? Area of a semicircle is half area of a circle. Area of a circle is pi r squared, or half of that. So we get half pi times r squared. Remember the r is 2, you know, not 4. So we're going to put 2 squared, half 2 squared. What did we do here? We use the area of a circle is half pi r squared. I'm just indicating that's what we did. And then pi is 22/7. Did they say that? Pi is 22/7. Did they tell us what to use for pi? They don't tell what to use for pi. Use a pi on a calculator. So this question did not tell us what to use for pi. We're going to use a pi on the calculator. All right? So let's go. I'm going to put that in the calculator right now and get that end area, which is a cross-sectional area. Here's my calculator. So no one calculator. I don't need to add up the pieces. So it's this part is 16. 4 4 is 16 plus this is half of the 4 here. So give me 2, don't it? Don't it? So it's 2 times pi, that's right? So I'm gonna do 2 pi, 2 times pi, 2 times pi. That's 22.28. 3 significant figures when the answer is not exact. So I'm gonna put 22.3. So the end area is 22.3 centimeters squared. Done. Halfway there. Now I need the curved surface area. Perimeter of the end times the length. All right. So how do we get the perimeter of the end? Let me put everything in one for you. Put everything in one. So I'm going to do the perimeter of the end, the L. So the perimeter of the end, which is the P, or end perimeter. Let's call it end perimeter. End perimeter. So we need it for the curved surface area. becomes equal to, what's the perimeter now? It is this 3 times 4 at the top there, so don't it? Calculating the perimeter. All of this red thing here, so I'm gonna mark out in red. All of this red thing here, so. Remember, you have to go around. You can't go across. Perimeter don't go across. So this piece in here not included in the perimeter, guys. This piece across here is not a part of the perimeter. Perimeter is this and around the boundary. Can't include in the piece that goes across the boundary. All right, so we need the total length of this perimeter in red. So you have the 4, 4, and 4 up there. So they have this half of a circumference down there. So you see that? But I can't see that. That add up to the perimeter, right? So it's 3 times 4 and half of a circumference. Now a circumference is 2 pi r. So half of a circumference is just pi r, don't it? So this circumference here, so just pi r. That's right. This circumference here, so half of the circumference, sorry. This arc length, so half of a circumference, just gonna be pi times r. So that's how we're adding up, right? So the perimeter at the end right now becomes equal to 3 times 4. But I say that? That's at the top piece. 4 plus 4 plus 4. 3 times 4. Plus the pi times r, the length of that arc piece. Pi times 2. This is the pi r. Put this in the calculator, we get the perimeter of the end. Let's calculate it. Where the thing gone? So it becomes 3 4s is 12 right here, so. Plus, this is 2 pi. Plus 2 times pi. That gives me 18.28. I'm going to put 18.3. I'm going to put 18.3. 18.3 centimeters is the perimeter of the end. Ready? So I have a P now. So I have a A. I have a P. What is my L? My L is 12 up here, so don't it? No, sir? The distance between the two ends, with that vertical, horizontal slant, the distance between the two cross-sectional ends is your length, your L in the formula. So I can write it right here. So my L is 12 centimeters. I have everything we need now, you know. So see here now, total surface here, to put this part in purple now. So let's add the blue as me just working out what I needed. I'm going to calculate it now. Total surface area, remember, is curved surface area, which is the perimeter of the end and the length. This is the curved surface area, plus 2 times the end area. The end area is this thing right here. See here, so that's at the end area. Let's put in the values now. The perimeter of the end is this, 18.3 times the length, which is 12, plus 2 times the end area. The end area is 22.3. 2 times 22.3. Put all of that in the calculator and put 70 centimeters squared on it. I'm good to go. So it's 18.3 times 12 plus 2 times 22.3, 264.2 centimeters squared. 264.2 centimeters squared is the total surface area of that prison. I did it nice, easy way. But good at that so far? But in here good? Online? But okay online so far?
Yes.
People online not responding at all. All right. Next part said. Next part said. Calculate the volume. Easy. The volume becomes the cross-sectional area times the length. And you have both of those, right? The cross-sectional area is what? The 22.3. Where is it? The A. See it here? This is the A, right? Put it here. So this is the A. Cross-sectional area is our A. Cross-sectional area is the A in our formula. So it's 22.3 times 12. The length is 12, right? Up here. Length is 12. 22.3 times 12. So this becomes 22. What for the purple, Mr. Shaw? 22.3 times 12. That gives you your volume. 22.3 times 12. That's 267.6 centimeters cubed. Volume is centimeters cubed. But good? Moving right along. Next part now says, the solid is made of gold. 1 cubic centimeter of gold has a mass of 19.3 kilograms. All this says, the statement says, is that 1 cm cube of your gold is equivalent to 19.3 grams of gold. 1 cm cube of 19.3 grams. And then it says 1 gram is for this amount of money. 1 gram is for this amount of money. And the question is asking us to calculate the cost to make the gold. Looks like we're going to multiply the 3 figures to mean. Because this is the total volume. If we multiply by this to get the total mass of gold, and we're going to multiply that total mass of gold by this money to get the total money. So we're going to have to multiply those 3 figures. But understand that? You get the cost, right? Because see here, this is the total cm cube of gold that we have now. So to get the mass of gold that we have to multiply by 19.3 because 1 has this amount of gold in it. And then after we get the total mass of gold, we're going to multiply by this money to get the total money for everything, right? So essentially we're multiplying those 3 figures that have circles. So we can just do it. Figure it out, just do it. So the cost becomes the total volume that we have, which is 267.6. Multiply by the amount of grams that is in 1 cm cube. Tell you the total grams that you have, which is 19.3. So this becomes the total grams that you have now. And then now, each gram is for this amount of money. So since this is the total gram, we're going to multiply by this amount now to get the total money. So I multiply that now by the $42. $42.62. That will give you the total cost. All right, as simple as that. So it becomes 267.6 times 19.3 times $42.62. So it's money 220,118. I'm gonna put it in cents, 66 cents. Get down to the cents. That is the money for the gold. That is it. Somebody else was asking for another question on this paper.
Question 10.
Question 10 on this paper. All right, number 10. All right. Number 10 right here. All right, so that's a matrices transformation. Like everybody good with matrices so far. But this is a transformation with matrices. That's what this is, right? So this question says transformation matrix A, which is this one, which everybody should be able to look at it and know what it is. It's an anti-clockwise 90-degree rotation about the origin. Yes, that's what it is. You should all know the matrices on site. This one is a reflection line y equals minus x. That's what they have said. It says, write the coordinates of P prime. Write the coordinates of P prime, the image of P, after it undergoes an anti-clockwise 90-degree rotation about origin. So this anti-clockwise 90-degree rotation about origin is done with this matrix. So applying this matrix to the point P to get the image. So how do you apply it? You apply the matrix to the point, to the vector of the point. So you're gonna go 0, -1, 1, 0. That's the matrix for 90-degree anti-clockwise rotation. The vector for this point P is 7, 11. When you multiply those, you're getting the image. So basically, let me shift this down a little bit and see what is happening. So our calculation goes that you apply the matrix to the point to get the image point. That's what this is now. So this is the A times the P. And we'll finish multiply that now. We'll have the P prime over here. put this in a different color. So essentially that's what we're doing. All right, we're getting the P prime over here. So how do we get the values inside here now? Remember, we multiply matrices, you multiply the rows of the first matrix, these two rows, by the one column. So this first value that we want, it is in the first row and the first column. So to get it, we have to multiply this first row by this one column. It's actually just one column. You multiply the row and the column, first element times first element, second element times second element. Some people say along the row down the column, it's the same thing. First element in the row by the first element in the column, second element in the row by the second element in the column. So it's 0 times 7 and negative 1 times 11. The 0 times 7 is 0 and negative 1 times 11 is negative 11. So the 0 is immaterial. This is just negative 11. Then the second value here, it is in the second row and the one column. So to get it, we have to multiply this second row by this one column. Multiply them the same way again. First element times first element, second element times second element. So it's 1 times 7 and 0 times 11. The 1 times 7 is 7. The 1 times 7 is 7. And the 0 times 11 is 0. So the 0 is immaterial, so the result is 1 times 7, which is this 7. But the question, you can't leave this as the answer now, because the question asks for the coordinates. This is just the position vector of the point. You have to write the coordinates now with the same values. So the P prime will have the same values in the position vector here, which is negative 11, 7. So this right here is really your answer. The question asks for the coordinates. This is how you write coordinates. All right? So that is that. P prime. All right. Next part now. Next part now says T is a combined transformation, A followed by B. That's a combined transformation. A followed by B. It says determine the elements of the matrix transformation T. So see here, T is A followed by B. But A followed by B is B times A. Second transformation times the first one. So see here, the T is A followed by B. That implies that T is equal to B times A. You have to multiply them in the correct order, because matrices multiplication is non-commutative. You can't just multiply them randomly. You have to put the B1 in front of the A1, because it is A followed by B, the resulting single matrix. You multiply the second one by the first one. So you see B times A. So you have to multiply them in that order, otherwise the result is going to be different and wrong. So you multiply the B matrix by the A matrix. But the B matrix was the reflection matrix, 0 minus 1, 0 minus 1, minus 1, 0. And the A matrix was the rotation one, 0 minus 1, 1, 0. So basically multiplying those two matrices now, same way, rows of the first matrix times the columns of the second matrix. All right, so this question is also testing our ability to multiply matrices. This is going to give us a nice big 2 by 2 matrix as our answer with 4 values. 4 values. The first value for here is positioned in the first row and the first column. So to get it, we multiply this first row by this first column. Multiply them the same way again. First element times first element, second element times second element. First element times first element, second element times second element. 0 times 0 is 0, negative 1 times 1 is negative 1. 0 and negative 1 is negative 1 here. Then this value over here next is in the first row, second column. So to get it, we multiply this first row by the second column. First element times first element, second element times second element. First element times first element, second element times second element. 0 times negative 1 and negative 1 times 0. So everything is 0. So this value is 0. Then this first value down here now that we want, it is in the second row and the first column. So to get it, to multiply this second row with this first column. First element times first element, second element times second element. First element times first element, second element times second element. -1 times 0 and 0 times 1. Everything is 0. -1 times 0 is 0, 0 times 1 is 0. This value is 0. Then the last value out here that we want is positioned in the second row and the second column. So to get it, we multiply this second row of the first matrix by this second column of the second matrix. First element times first element, second element times second element. First element times first element, second element times second element. -1 times -1 is a positive 1. 0 times 0 is 0. 0 is immaterial. This becomes a positive 1. That is the matrix for reflecting over the y-axis. You have to know the matrix is on site. All right, so this is answer now. That is it. Then they ask us to describe geometrically the transformation T. This one. You have to know it on site. Who marks for us knowing that, you know? Why go in the exam to figure it out where you cannot know it? That's the matrix for reflecting in the y-axis. All right, so T is a reflection in the y-axis. That is it. Anything else? Down here. It says the 2 by 2 matrix C determined is in terms of a scalar constant K is given by that. It says determine the value of K given that the matrix C is singular. So if it is singular, it has no inverse. Has no inverse when it is singular. And when it is singular and has no inverse, that's because the determinant of the matrix C is equal to 0. When the determinant is equal to 0, the two diagonal products equal. The first diagonal product is equal to the second diagonal product. So that when you subtract them, that's why you get the 0. So when it's singular, the diagonal products are equal, right? So you can do it that way. So it means that the 3 times 4 is equal to the 6 times K. 6 times K. Now this is 12. Now for this side to be 12 as well, the K will have to be 2. So we can say therefore the K is equal to 2. And that is it. The diagonal products are equal and the determinant is 0. That is that. Anything else on this question? Want this part as well? Want to see as well, mom, online? Say yes.
Yes, sir.
Beautiful. She said yes. She said yes. She said yes. She said yes. Let's go. Let's go. Let's go. This question says, in the diagram below, O is the origin, and the vector OX is U, and the vector OY is V, and they are showing them here, right? It says O and X are extended so that X and Y are midpoints of OA and OB. So this is the midpoint of this whole line, and this is the midpoint of this whole line. Now watch this now. It means that this length and this length is the same, and they are also parallel, so they are equal vectors. So if this vector is U, then the vector up here is also U. Right? Up here is also U. Same vector. U like this one. So OA then is 2U. OA then is 2U. Similarly down here, if this vector is V, this length and this length is the same, and they are in the same direction, parallel and everything, same straight line, and they have the same length, then the vector from Y to B is also equal to V. So I'm going to put it on here. The vector from Y to B is the same as this, V. So it means that OB is 2V. The vector OB is 2V. So we know that. So sometimes the more position vectors you know, the better, right? So look at this now. Based on that information, guys, we can write down a couple of things. We can write down other position vectors. So we have these that we know. And we have just determined that OA is 2u. So let's write it down as well. OA, the vector OA is 2u. You see, guys, you see? Put an arrow on top of the vectors. Put it on. The vector with, if you write this without arrow on top, you're not talking about the vector, you're talking about the length of the line. You have to put the arrow on top of it when you're talking about the vector. And the vector OB is very important. You have to put the arrow on top. OB. You can't put OB equal 2V. OB is not vector OB. OB is the length of the line OB. If you don't put the arrow on top of it, you have to put the arrow on top of the vector. Because the vector is basically where you go around the object from point to point. That's what the vector is. That's direction in it. You get me? Good. So you have to put the arrow on top. Everything important. They will take off marks for those things. If you write in a vector and don't put the arrow on top. Now look at what I did. I underlined these letters to differentiate them as vector components. They write them in bold or italic letter. I can't bother with the bold italic. I just underline my vector components. Same difference. The small letters. When I use the common letters for vectors, I underline them. When you use the capital letters for the endpoint of a vector, you put the arrow on top. Hey, everybody come class one. Huh? Because I start videotape now. So you don't get to no grade, but just come to and send come go. So you see that there. All right, let's continue. Tomorrow exam is still a joke. You can't take like 1 day serious. Tomorrow exam, Let me give a question you can't do it. You know say you can't do it. I'm not ask you. You cannot do it. I'm not paying attention to tomorrow exam. You cannot do it. Anyway. Can't help me and put it in here. Anyway, next question. Let's say I must calculate the vector bx. So look here. Since I know the position vector of the b, I know OB, and I also know the position vector of the x, I can use the displacement formula. Displacement vector formula. O times the last minus O times the first. I can get it from the diagram now. But when you know the position vector of the endpoints, you use O times the last minus O times the first. So this bx that I want right here is equal to OX minus OB. O times the last minus O times the first. O times the last minus O times the first. So the OX is just this U. Right? And the OB is 2V. So we're going from B to X. So this becomes U minus 2V. That is it. To go from B to X. And look here, we could show it now. We could show it on the diagram as well. To go from B to X right here. Look. We could come back this way from the B. Come back this way. That's a negative 2V now, because we're going in the opposite direction to the 2V. Negative 2V. And then when we reach O, it just comes a boom. And go up to the X this way. That's the plus U. See that? So you could have put negative 2V plus 2V. But when you have the position vector of the endpoint, use O times the last minus O times the first. All right? That is it. All right. Then now, next part now says that given that YA and YB intersect at M and that BM is equal to 2MX, express BM in terms of U and B. So I want to interpret the information. Really, it's a breaking of the line into parts. That's what that information is about. Most times, the questions in C-set will break the line into the ratio 1 to 2. 3 parts. So one part is 1/3, one part is 2/3. We have seen as well that there are broken lines in the ratio 1 to 3. One part is 1/4, one part is 3/4. You get me? So what you can do to determine is put this information on the line itself. BM is 2MX. So since BM is 2MX, BM is the longer piece, you know, because it have 2MX in it. Watch this now. I want to put this information on the line and the ratio work out itself for you. The length BM has 2MX on it. So I'm going to put that on the line to see it. You don't have to figure it out. So first they intersect. They said they intersect, right? YA and BX intersect at M. So let's draw it. All right, YA and BX. So YA is this line from Y to A. Like this. This is the line YA. Let's draw it better. That's line YA. And then BX is from here to here, right? Between those 2 points. So I'm going to try to draw my best straight line down there now. Bam. All right, good enough. We work with that. All right, we're talking about right here. That is M. All right, that is the line M. That's the point M. Now, what did they say? Let's look back at what they said. They said BM is 2mx. Let me write it here. So BM is 2mx. Means a BM of 2mx on it, you know. See BM right here, so watch this now. I'm gonna put the 2mx on it and show you. So the BM right here, so have 2mx on it. 2mx. And the mx is just 1mx. So the mx is just a mx. It's just a 1mx this. See that? If I rub off the mx them now, bam, bam. So the line is in the ratio 2 to 1. Simple as that. See that? So this part of the line is 2 parts. This is 1 part. Total parts is 3. See that? The entire line is broken down by M in the ratio 2 to 1. So all of this represents 2/3 of the entire line, XB. And this piece is now 1/3 of the entire line, XB, BX. I think they calculated the BX. See the BX there? So what the M is doing is breaking up this BX that we have calculated in a 2/3 piece and a 1/3 piece. So let me see it again. Show you again. So this piece right here, so is 2/3 of BX. See the BX here now. Right? That's the BM. And this piece right here is 1/3 of the BX. 1/3 of the whole thing. See the BX here, so the part up here so now is 1/3 of BX. 1/3. All right? And you're gonna have to travel those parts of the line, I guarantee you. All right, so leave the ratio on it. So that's our way to get the ratio on the line, right? If you have an easier way, I can see through it, no problem. 2/3 and 1/3. Let's continue down here now. So the question wants us now to calculate the vector BM. See it here? Express BM in terms of U and V. So we want to go from B to M now. Let's look at it. B to M. Easy. B to M is just 2/3 of BX. See that? So I'm going to B to M. It's just 2 out of the 3 parts of the BX. The whole thing is BX. So B to M is 2/3 of the way. So it's 2/3 of BX. Let's write it down as so. BM is just 2/3 of BX. BM is simply 2/3 of the whole BX. What was the BX again? Let's write it here. So let's write it right on the screen in front of us. The BX was, what is it again? U minus 2V. It was U minus 2V. Now we're just calculating 2/3 of this guy right here. So now I see it. Right? So I take 2/3 of each part. Right? So 2/3 of this part, give me 2/3 U. And then 2/3 of this, 2 times 2 is 4. So I get minus 4/3. 4/3 V. That is my BM right there. But good at that so far? But in here so good?
Yes, sir.
Yeah, my boss? You sure? You can do question, I'm gonna find out, you know. Give it. All right, online, so them good. Hold on, I'm not done yet. I'm another part. Hold on. Not done yet. All right, see, sugar part of the question here now. Huh? Now watch time, I have about 3:12. Next part now says use a vectors method to show this ratio. Look here. You see the questions in CSEC? Questions in CSEC, the extent of the syllabus is parallelism, parallel vectors, collinear points. Whichever way they want to set it. This relates to the same method you use for parallel vectors and collinear points. Same method. Same approach to get to this. To get to this, the same steps. Right? What it is that the 3 points are on a straight line, Y, M, and A. Look at it. Y, M, and A on a straight line. Look at the diagram. See them, man? So why them Y, M, and A are on the same straight line. So it's a collinear point application. You get me? How do you show collinear? Parallel vectors with a common point. So if we still go through the parallel vectors business, right? So to get to this ratio that they wanted to do, down here. To get to this ratio that they wanted to do, we have to go calculate ym and calculate ya and compare them, two vectors, and say use a vectors method, right? So we're going to calculate ym and ya, but we have the ym already. No, we don't have ym. We don't have any of them. What a question, wicked. We don't have none of them. Usually they'll give you one of them, you know. All right, don't give it. You don't have any. You have to work out the two of them. Osh. You have to work out the two of them. So I need to work out ym and ya, and then show that them have a 1-to-3 ratio. Pay attention to the process, guys. Exam is tomorrow. You don't seem to do it one time. Similar to your collinear points or parallel vectors. So calculate the ym, calculate the ya. What we do? Get rid of fractions, don't it? So that they can equate. Right? That's the first step. Get rid of the fractions, adjust them so that they can equate. When you equate, you get out the vector component, you see what multiple ym is of ya. And then to get to the ratio now, there's one additional step that you have to just get it today. All right, let's go. So we need the ym and the ya. So let's look at the diagram. Might be easy. The ym and the ya. All right, so the ym first. The ym, to get the ym, we have to come out here so first. And then go up there, so right? But let's answer that. Look again. To go from y to m. You have to go down the vector redirection that you know. We just work out a vector here a while ago, you know. There, don't it? Draw it in blue for you. To go from y to m. I can come out to b first with a v there, so right? And then use the bm with the calculator and come up to the m. You see that? It's vectors, you know. It's how you go from point to point. All right, so I'm just work it out right here, so I'll show you. So, sit here to go from y to m. We're going to go y to b first, and then go from b to m. The y to b is just this v. Plus the bm is what we just calculated down here. What was it? The bm. See here, we just calculate this bm here, so. I'm copy this up here, so and put it there.
2/3.
Yeah, hold on a second. Copy. Just copy and paste it right up here, so. Where the working is. Let's paste it here and make it small. So we're gonna just paste it here. See it there? Click a smaller step. See there, that is the BM. Right? This is the BM we just calculating now. Is it using back now? And then you're gonna consolidate the values, right? Consolidate the V's and consolidate the V. You don't want to have two V terms in it and two U terms in it. You want one V term and one U term, the vector components. So this is the only U term in it. So I'm going to write this as 2/3 U. 2/3 U. That's the only U value. Then I have this whole V minus 4/3 V. Look what you can do. You see this whole V right here, so? You can write it as 3/3, make it have the same denominator as that. And then you realize that what we're really doing is 3 minus 4. So you get negative 1/3, right? Or you can say you have a whole V minus 1 1/3 V, because this is really 1 1/3, you know. So you really left with minus 1/3, right? So you're gonna get minus 1/3 V. Minus 1/3 V. Minus 1/3. I want the purple. Come on. Purple. Minus 1/3 V. All right, so that is my YM right there. All right, let me copy it and carry it down on the next page here. Normally they give you a question where you actually have a vector already. All right, but they didn't do it this time. So I'm going to go and paste it down here as a vector that we need for this calculation, all right? That one, paste it here. Paste it here. All right, let's put it right here. So we'll let this up for the time being. We need YA now. We need vector YA now. This one might be easier. YA easier. Look at YA. Can look at it and see YA. To go from Y to A, easy. We can come back V down there, so, and then go 2U up there, so don't it? So it's minus V plus 2U. But can see that? Come back this way, which is a minus V, and then go up there, so 2U. So Y to A is minus V plus 2U. Let's write it out. Diagram shows you. So to go from Y to A, we're going to go from Y to O first, and then we're going to go from O to, because it's O time last one, it's O time the first two. Now let's do it that way. Cover the position vectors. Let's do OA minus OY. Since we have the position vectors, let's do it that way. So I use a diagram. So the OA right here says 2U. And the OY right here says V. So you're subtracting V. Same thing. That is the vector YA. All right, let's carry it down now. Copy this. Cut it. Paste it down here, so now. Right here. All right. So now we want to compare these two vectors. Let me put a YM on this. We want to compare this vector with this vector, YA. We want to show that one is a multiple of the next. I can look right away and say, this is actually 3 times that, you know. But let's say I can't see it. What do we say we do in the class? Get rid of any fractions first. Why we get rid of fractions? Fractions make it more difficult sometimes to see the relationship between numbers. It's easier to see the relationship between 9 and 3, for example. The 3 times relationship, don't it? It's more difficult to see the relationship between, for example, 5/7, and 3/4, don't it? More difficult to see what multiple is that one of the other, right? So you get rid of fractions. When your vectors are in fraction form, you want to see a clear relationship between them. Get rid of the fractions. Rewrite it without the fractions. Rewrite it, adjust it so it don't have fractions in it. So to get fractions out of this one, that's the only one with fractions. I would have to multiply 2 by 3. The lowest common multiple in the denominator is 3. Get rid of it. So if I multiply this equation here by 3, the fractions will be gone. If I multiply this side by the 3 first, I get 3ym equals, when I multiply this by the 3 becomes 2u. Multiply this by the 3, I get minus v. Beautiful. I now have the 2 vectors that I can equate because the 2 of them equal the same thing now. See that? So them 2 things are equal. It means then I can equate these 2 things now. Because the 2 of them equal the same thing, right? So now I can do a thing we call equate. I can now equate them. Let's do it right here. So we can now equate them because the 2 vectors equal the same thing now. So we see it now. We can see now that the YA is 3ym. But then we can have the ym in front, you know. So we write it that way there. When I write now that the 3ym, watch this part now, you know, guys, is equal to YA. So at this stage now, we need to go from this vector equation to this ratio now. That ratio is a ratio, really, like a fraction. But what's the problem now? The problem is that these have directions in them. And you can't divide direction. You cannot divide distance and length, right? So if you get the direction out of these vectors, or you get the direction out of them, you take the modulus of both sides. And the modulus is now getting the length of the vectors. So when I take the modulus of both sides, like this, take the modulus of this side of the equation and the modulus of that side, I can just drop out the arrows. You get me? I'm now going to the length of the lines. And so that's how the arrows are dislodged. And so I get now 3ym. This is now the length. 3 times the length of ym is equal to ya. That's what we're basically saying now. We're not talking about vectors anymore. We're now talking about the length of the lines. To get this ratio, you see that ratio here? Let me show you something now. See this ratio here? It is just another way of representing ym over ya equals 1 over 3. It's the same thing. And that's what we will get with this if we cross divide. So we take this ya and divide it under here. and take this 3 and divide it under here. We get that thing there right there, so. Look at it. Somebody say you can't do it. Can't do it. So I cross divide now, I get ym over the ya equals. When we divide the ya under here, somebody left with a 1, don't it? 1. And take that 3 and divide it under here now. We get the 3 under here. So you see that? And when you get that ratio, then you can draw the conclusion. Therefore, ym to ya equals 1 to 3. Shown. Nice. See that? See that? Can do it? Keep saying yes. All right, make sure you know. Always stay body good online. No, that is that it. No.
Yes, sir.
Yes, sir. Yes, sir.
All right. So when you have a question, somebody have a question? You have a question? You watch the video? You watch the video I'm telling you to watch? Huh? Wait a second. The video we talk about before the break. You watch it? That's what I ask you. I was asking if you watch the video before the break that we spoke about. That's it. You know, watch it. The video about 5 minutes of 20 minutes. Come on. I'm going to watch the video, man. Which question you have? Come question. Which paper is this? 2024. Hold on, no? 2024, question 10B. B to do the stick, you know. Come tell you, watch the video. Alright, right. This which paper is 2024 January. Oh, January. It has to be January. Alright, let's do this. Hey, stop talking, stop talking. All right. This young man wants his question. Number what is 10? Number 10. This is it, right? Yeah, it is. All right. You can fly through this one in a jiffy. Because it is very easy. All right, let's go. This question says, PQ. Somebody in the class wants this question. Shouldn't want this question, but it's all right. It says PQ and R are given below in terms of scalar constants A, B, and C. P is this vector, that the A in it right here. Q is this vector, that the B right there. R is this vector, that the C right there. It tells us that P plus Q equals R. It simply means that this vector, this matrix, sorry, plus this matrix equals this matrix. That's all it means, you know. How do you add matrices? You add the corresponding values. So it means, therefore, that a value here plus a value here equal a value there. See that? See it? You add the corresponding values, then equal. Because you're adding them. That's going to give us the first one. Give us one of them. Stop talking, man. Now get me upset, you know. 3 minus 1 equals C. 3 minus 1 is 2. So C equals 2. Done. Next one. The B. See the B right here, so. So the B there plus a minus 9 that equal a minus 3 there. See that? We add the vectors. That's why we add the corresponding values. So the minus 9 plus the B equal negative 3. See there? Minus 9 plus B equal negative 3. You want to find B? Take the negative 9 and carry it over this and add it. So the B equals minus 3 plus 9. That is 6. Done. Huh? That's not easy. Huh? Not joke, man. Then now the next question. This is exam easy, and I think I like me to tell. This x value is what? A. The A here plus the minus 4 here equal minus 4 there. So they equals 0. That means no calculation. If A plus minus 4 still equal minus 4, then they are 0, don't it? That's all? A equals 0. A equals 0. I want to show some work. A and minus 4 equal minus 4. So A equals 0. All right, done. That's A, B, and C. Next part. Solve the pair of simultaneous equation. Use a matrices method. Easy, quick and fast. Write the matrices equation. They're in the order already, friendly order. X followed by a Y, X followed by a Y. So this matrices equation becomes a 2 by 2 matrix times a column matrix XY equals a column matrix with these two values, 44 and 10. And the values going in this matrix are the coefficients that came from this. 5 and negative 2. 2 and 3. I'm showing you something from now. Watch this. If your two equations were, for example, like this. 2x minus y equals 5. And for example, minus x plus y equals 15. Pay attention. Your equation would have been like this. Still xy equals 515. Coefficient of this is 2. Coefficient of this is negative 1. So you don't see the number in there. It's a 1 in there. Imagine a 1 in there. So you put a negative 1. This one also be a negative 1 in front there. There's a negative 1 in front there. So the coefficient will be negative 1. This two have the number in front, but there's an imaginary 1 in there. So here will be a 1. See that? Can't put the x and y inside, so you put in the coefficient of the x and the y. If there's no number in front it, shown, it is 1. But understand that? Understand that? But I go to sure. All right. You can answer Mr. Shaw never telling.
So can you go over question 6 in this paper?
Hold on, I'm finish this one first. Let's finish this one first. All right. And then now, simple matrices transposition, what you know, says that this thing here, so, is going to go in front here as the inverse. Must go in front. On the front here, because matrices multiplication is non-commutative, you have multiplied the inverse on the front. All right, so the xy is going to be equal to the inverse of this matrix. Let's put the minus 1 on it for the inverse. Times the matrix 44, 10. Is what happened. Times 44, 10. So we need to calculate the inverse of this matrix. We'll calculate the inverse of that matrix. 1 over the determinant times the adjoint. So it becomes equal to 1 over the determinant. Order the determinant. This product minus this product. This product is 15 minus this product is negative 4. So you're subtracting a negative 4. That minus minus becomes a plus. So under here the determinant is really 19. Minus minus is a plus right here. So it's really adding them. They multiply that by the adjoint of the matrix. Or you do the adjoint. They interchange the elements on the first diagonal. They interchange them. So you put in 3 here and 5 there. They leave these two other elements where they are and change the sign. So this negative 2 stays where it is but becomes a positive 2. This positive 2 stays where it is becomes a negative 2. I did not switch them around. I changed the sign. I look like I switched them around. But no, I actually just changed the sign. Just coincidental. And they multiply back by this matrix, which is 44, 10. So this right here now is really the inverse. This. All of this is really the inverse. They don't give a lot of space to work. We're going to continue, all right? What you normally do when you reach here, so you multiply out here. Multiply out here. Leave the fraction outside for last. Right? Multiply out the matrices with the whole numbers. Leave the fraction outside for last. 1 over 19. Leave it for last. All right? So I'm going to go now and put this as equal to 1 over 19. Then I'm going to multiply these two matrices now. I'm multiplying this times this. Same thing again. First element times first element. Second element times second element. So it's 3 times 44. 3 times 44 is how much? 3 times 44 is how much? 3 times 4 is 120. 120 plus 12, 132. 132, right? That's right? 132, and then the 2 times 10 is 20. So it's become 152. 132 plus 20 is 152. So this is 152. Then the value right here now is this row times the 1 column. So it's minus 2 times 44, which is negative 88. And then the 5 times 10 is 50. That's become negative 38. So right here is negative 38. Negative 38. All right. And you divide each of those values now by the 19. So you divide this by the 19. 152 divided by 19 is how much? 152 divided by 19 is how much? Quick, quick, quick. Huh? 8. So you get 8. And this divided by this is negative 2. So the xy equals this now. Sorry, what happened here, sir? What happened there? Sorry about that. So if the xy equals that, then the x equals the 8, and the y equals the negative 2. So I write the answer here now that the x equals 8, and the y equals negative 2. That is that. Hold on a second. So somebody want number what and this question? Number was 6, you say? Or 5, what you say? Online?
So number 8 instead.
Number 8. Okay. Give me a second. Hold on a second. Which question you want again? Number 8, you said?
Yes, sir.
All right. Number 8. All right, let's do this. Coordinate geometry. And I noticed in recent time, they put in some coordinate geometry in section 2. All right. Start question 2 on the function. All right. Question said, diagram below shows the graphs of two functions on the same pair of axes. So the lines G and H are perpendicular. These are just straight lines. So even though they call them G and H, it's still a y equals mx plus c situation. Still a straight line situation. Still a coordinate geometry situation. Still a y-axis intercept, gradient, parallel line, perpendicular line situation. No different. They say them perpendicular, so automatically they have negative reciprocal gradient. If you know the gradient of one, you flip it and change the sign and get the gradient of the other. Oftentimes, when they give you the information on a graph like this, minimum calculation needed. So if you want gradient, for example, you can count off the gradient, count the rise and count the run between 2 points. For example, you don't have to calculate. You don't have to put on the coordinates and calculate the difference in y for difference in x. That's why I like the graph ones. You can see y-axis intercept. For example, here we can see the y-axis intercept is 3. And from these 2 points, we can count off the gradient. We don't have to calculate the gradient. You can just count it off. All right? So let's go. So this one says, we don't want the equation of line G. Yes, naturally we want the equation of line G because that is one we have more information about. We have 2 points on it. All right. So to get the equation of the line, we need to know 2 things about it. The gradient and a point. The point that we know is the y-axis intercept even better, okay, because y equals mx plus c. So first for line G, the c is obviously 3. So for line G, the c is 3. We need a gradient next. You can use these 2 points to get the gradient. Easy. Count the rise and the run between these 2 points. Let's look at it. So from this point to this point, always go from left to right. See what the rise is over the run, go from 2 points from left on the line to right on the line. So how much would we have to rise? We are on the x-axis. To come up to this level, we'd have to rise 3 units. So the rise is 3. Then to go from -6 to reach the y-axis, where this point is, we'd have to run 6 units. So the run is 6. We have the rise and we have the run, we have the gradient. So the gradient of line G is simply 3/6, which is a half. So see it here, the gradient of line G is rise 3 over run 6. 3/6 is a half. So gradient is that. And the equation now, since we know the m and the c, the equation is in the form y equals mx plus c, which is y equals half x plus 3. Easy like that. All right, we're talking about line G. So let's put mg. Done. So remember the line's perpendicular now we know. Now they want us to tell the equation of h. So look at the line h now. Remember it's perpendicular to the G line, you know. So we can write that first. The gradient of line H is -1 over the gradient of line G. Gradient of line G, remember, is a half. Flip this half and change the sign. That's how you get the perpendicular gradient. Flip the one that you have and change the sign. So if we flip a half, we're going to become 2/1 and then change the sign. -2/1 is -2. So the gradient of this line is -2. Or if you want, you can take the half and put it under here in the calculation, but that's a waste of time. This becomes -2. That's a gradient of line H. What else do we know about line H? We need a point. To find the equation of a line, you need the gradient and a point. Any point. The point that we know is this one, not the y-axis intercept, the x-axis intercept. That point here on line G has coordinates 4, 0. That is enough. 1 point and the gradient will give you the equation. When you use the other method, some person will still use y equals mx plus c, put that in it and calculate the c, and then write by the equation. If you do it that way, no problem. But I'm going to use, let's call this point, since I call this one P, let's call this one Q. So I can reference it, right? So line H, I'm saying it passes to the point Q, 4, 0. So I'm going to use this gradient and this point to get the equation using the BFF formula for the equation of a line. The point gradient format. Point gradient format. Which is why the equation, right? The equation becomes y minus the y value at the point that we know, which is Q, equals the gradient of a line that we want, gradient of H, into x minus x value at the point. X value at the point is Q. We're putting in these three values in this equation in the right place and get the equation. Let's go. Y minus the y value at the point is 0 equals the gradient is this negative 2 there, into x minus x value at the point right is 4. So subtracting 4. This y minus 0 is just y. This is minus 2x. And this minus 2 times minus 4 is a positive 8. And that is it. That's the equation of H. The next part now says, we have to find the coordinates of P and show working. Now let's look at it. P is the point of intersection of the two lines. If you want to find point of intersection, you solve the equation simultaneously. Find the point of intersection, you solve the equation of G and the equation of H simultaneously. So P is the point where the two equations become equal, right? They become equal, they become the same. The values on each equation is the same for the x and the y. So at P, sit here, at P. What does that mean at P? First equation is valid. What was it again? Y is equal to half x plus 3. Y is equal to half x plus 3. And also, this equation is valid at the point P. Y is also equal to minus 2x plus 8. Easy because they put y as a subject. We have y as a subject of both of them. So the y value on the two lines is the same at the point. Y value at the point P on the two lines is the same. So the y value here and the y value here is the same. So it means that this is equal to this at the point, right? They equate them. That's one way to do it. That's not the only way, but we can equate them. So at the point P, since y is equal to this and y is equal to that, and the y value is the same, then this and this equal. So we can say half x plus 3, that's this one, comes equal to this one, minus 2x plus 8. And we're solving that. Multiply 2 by 2 to get rid of that fraction. You get x plus 6 equals minus 4x plus 16. Then I'm going to take this and bring it over here and add it to this, give me 5x. Take the 16 and go and subtract over here, I'm going to get 10. Divide by the 5, I get x equals 2. When I get x equals 2, I can take this 2 and plug it into the x, for the x right there. So I get half x plus 3 is 4. So the y equals 4. So I can say, and the y equals 4. When I take the 2 and I put it inside here, I get half of 2 is 1. 1 and 3 is 4. If you like, you could put it inside here instead. You get negative 2 times 2 is negative 4. Negative 2 plus 8 is the same 4 here. So the y equals 4 at the point P. So it means that P is a point 2, 4. X is about 2, y is 4 at the point P. That done? Want this part as well, ma'am? Want this part as well?
Yes.
Online? I hear the challenge with this part now. This is complete in the square. But the challenge with this now, guys, is that more than likely the person online would have learned this different from XTYT that we do in the class, right? Cool? So now closing the eyes. We're not going to do it XTYT method. We're going to do it H and K method, right? But we're not going to do it XTYT now. Huh? Put the xt back into the function and get the yt. All right? So I'm going to do it the way that they more than likely learned it in their school. Everybody, everywhere else teach it with h and k, right? But in here alone, we do it with xt and yt, nowhere else, right? So because if somebody online asks me to do it, I'm going to do it h and k. So I'm going to wipe out this h and k out of the head now. Don't look. All right. I'm just doing it for the person online. All right, let's go. So if we're using the h and k method, the h is b over 2a because it's a plus that right here. Our method, we use x minus xt. And then our xt becomes minus b over 2a. You understand? All right. So it's a difference. All right. So we're using h and k. So we're going in this form, I use a formula method, guys. The h is going to be just b over 2a. Remember, no, we're going to use xt now. All right. The a and the b comes from the standard form, just the same. The a is the coefficient of the x squared right here, which is 4. The b is the coefficient of the x, which is negative 24. And the c is this constant value out here, which is 31. All right? And the h is b over 2a. So they are going to get b, bam, 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 which is negative 24 over 2 times a. And the a is 4. This becomes 24 over 8, which is 3. That's negative 3. The k can be calculated same here, but I'm taking this, well, it can't even calculate the same here because this is not xt, you know. It's a h. So you can substitute this back in it and get the k, you know. Because this is not xt, this is h. xt and h are two different something. A negative, right? So we can substitute it. So we calculate the k using a formula method as well. When we calculate xt, we can substitute back xt in the function and get the yt, you know. Get the k, you know. But when we calculate the h, I'm can't do it that way there. You get me? We have to calculate the k straight. Where the k now, that's the xt, that's the h, I mean, the k now is still 4ac minus b squared over 4a. That's the formula for calculating the k. All right? Some people write that c minus b squared over 4a. Can we divide by the 4a, they say get c. You see that? It's another way to do it. But anyway. So this becomes equal to 4 times a. 4 times the a, which is 4. That's why I prefer xt, you know. Now we could have substitute the xt back in this now and get the yt. See that? Like I get 3 for our xt. See it? But all right, let's do it this way. So 4 times a times this 31 minus the b now is negative 24. And square the negative 24 divided by 4 times a. 4 times 4. You'll put this in the calculator and see what simple fraction reduces to. I'm doing it for the person online. This is not the way we do it in our class here, mom, online. But because I know that more than likely this is how you would have learned it, I'm just doing it this way. But this is not the way we do it in this class. We'll do it in this class a unique kind of way. So can't but explain it now. 4 times 31 minus 24 squared. Negative 24 and 24 squared, same thing. So we're subtracting 24 squared. And then you're putting that over 4, 4, 16. Let's so I get negative 5. So this is negative 5. If you put the negative 3 in this, guys, you're going to get a positive 5, which is wrong. You get the opposite. You're going to get a different value. You're not going to get negative 5. You have to put 3 in there. Our xt would have been 3. All right? So that is it. So now that you know the h, you can write the function as, so the function becomes this thing that they wanted, this thing that they wanted. You can now be written as the a is 4 into x plus h, but the h is negative 3. So plus h is negative 3 squared. And the k is this. Minus 5. So you see this value here, guys, would have been our xt value, the 3. This will be x minus xt. So our xt would have been 3. See? But then calculate h, which is minus 3. See? Good. So the x value turning point is actually 3. But let me show you now. But their method now that says on the sketch below, they want us to sketch a graph, right? And that to indicate the coordinate of the maximum or minimum point. Now, first is going to be a minimum point. I know it's minimum. Because the A is positive. When the A is positive, we have to have a smile shape and we'll have a minimum point, right? A minimum value. So we're going to cross out this maximum. It's a minimum that we have. So what is now? So the minimum point, we use H and K. Coordinate of the minimum point. Look now, it becomes minus HK. That's the difference. When you use the H method, the minimum point or the maximum point becomes minus HK. See it? When you use X plus H method, you use minus HK. We would have just used XTYT, right? But they use a minus HK. So this would have been our XT. But they're minus H. Remember, you know, the H is negative 3, you know. So minus H would have become a 3 still, see it? So I get the same point. So the minus H would have still give you a 3 because the H is negative 3. So minus H is a positive 3. So the minimum point is 3, negative 5. The K is negative 5 right here. Negative 5. So that's where the minimum point is. All right. And then now the C is still a y-axis intercept. The C is still a y-axis intercept. And the graph still has a smile shape. So this turning point here, 3, negative 5 would have been in this quadrant, don't it? Where the x value is positive and the y value is negative, right? 3, negative 5 is over there. And it has a smile shape and it crosses the y-axis at 30, 31. 31 is up on this side of the y-axis. So what a smile that crosses up here and turns down here. That's what you want. So that's a smile. Let's draw it there. Let's draw it in blue. So we want a smile that turns down here and crosses somewhere up here. So we're going to just like that. Bam. Try it again. Bam. So we're going to put this point. It's as a sketch, it's not to scale. This point has our y-axis intercept 0, 31. And this is our minimum point. 3, negative 5. It's not to scale. That is it. And then here now, they want this equation of axis of symmetry. Axis of symmetry in our way is x equals xt. But their way is x equals minus h. Minus h. Still a vertical line through here. Axis of symmetry is still a vertical line up here. Is x equals the x value at this point, which is 3. That's the axis of symmetry. State the equation of axis of symmetry. X equals 3. That is it. X equals 3. This line is the axis of symmetry. So we do it our way with x and y2, we would have got the same thing. You get me? And that's it. All right. Hold on a second. All right. Any other question anybody want? Any other question? Huh? You don't want more question? Show of hands in here. No one question. Ready for tomorrow? Ready? All right. Remember, I'm going to talk. We're going to phone and leave. Online, anybody want any other question? It's now 4. We're going to close off. Anybody have any other last question to do? Online? No other question? We did the marathon and we do the factorization for you.
Oh, sir.
You need to go and watch it. And also we also did the variations for you because you asked for it. You need to go and watch it. All right?
Sir, can you do May, June, 2021?
2021?
4 and 10.
2021. All right. So doing those last 2 questions and then you have a question too? Call me there and say another question. You want to beat me? 2021. Which one? June 2021, you said?
Yes, sir. Yes, sir.
June 2021. Hold on a second. Let's find it. June 2021. Where's it? 4 and 10.
Yes, sir.
All right, 4 and 10. Okay, guys, I need to talk to you before you leave here. I need to talk to you before you leave. So we're gonna operate tomorrow in the exam room. You guys in here. Number 4 and 10. And 21, 4. Oh, it's a similar question to what we just did. Coordinate geometry. All right, let's run through this quickly. This question said diagram below shows two lines L1 and L2. The equation of L1 is this one, and they have it shown on the line here. And again, the two lines are perpendicular, so they have negative reciprocal gradient. And then this line, line 2, passes through 0, -5. So this is a C value on line 2. The C value is -5. This is a C value on line 2, C. All right. And because we have this equation, we can extract the gradient from it by putting it in form y equals mx plus c. All right. Let's see what they want us to do. Let's say express the equation of line 1 in the form y equals mx plus c. This equation. In other words, make y the subject. So see it here. We have x plus 2y equals 10. I'm going to transpose the x first and get 2y equals minus x plus 10. You want to multiply 2 by a half to get rid of that 2. Multiply 2 by a half or divide 2 by 2. Same thing. Multiply 2 by a half. So we can get y alone as a subject. So multiply 2 by a half. This becomes y. This becomes -half x. And this becomes a 5. This becomes a 5. So that is the equation of that line. Let's say state the equation of line L1, which is just this gradient right here. The gradient y equals mx plus c. The gradient is just -1/2. So the gradient of line 1 is -1/2. Simple as that. Next part. Once us determine the equation of line 2. Remember, line 2 perpendicular to line 1 and the perpendicular. Line 2 is perpendicular to line 1. So they have negative reciprocal gradients. So the gradient of line 2 is -1 over the gradient of line 1. Remember, the gradient of line 1 is -1/2. Come up here. See it here? So you're going to flip this -1/2 and change the sign. It's going to simply become a 2. That becomes 2/1. You flip it to become -2/1 first and change the sign from negative to positive. It becomes a 2. Then now, what else do we know? It have a y-axis intercept of -5, right? Line 2. They gave us that. What's happening here? I don't know what's happening here. It's doing its own thing. Everything gone now. Oh, all right, good. No, still bad. All right, back. All right, good. It's freezing up. All right, so remember for line 2, the y-axis intercept is of -5, right? So we have the c and we have the gradient. So then we can get the equation for line 2. So line 2 has this gradient and it has a c value of -5. Let me shift this up here. What's that? All right, so since you have this gradient and this c value, you can write the equation. The equation is y equals mx. This is the m. This is a plus c, -5. That's the equation of that line 2. All right. Then we continue. It says, you want this part as well? Online? Hello? Hello? Online?
Yes, sir. Yes, sir.
You want this part as well? All right. So it's our functions. F of x, g of x. You want f of 9. F of 9 means that we're going to plug the 9 into the f function there. So this is simply going to become equal to 1/3 of 9 plus 4. 1/3 of 9 is 3. This is 3 plus 4. This becomes a 7. They want f of g to the minus 3. This means f of g of negative 3 first. That's what it means. So it means that we're going to do the g of negative 3 first, which is to plug the negative 3 into the g function there. All right, so this is going to become f of, and then we'll put in 3 times negative 3 over negative 3 plus 1. So let's become a negative 9 over a negative 2. Negative 9 over negative 2, the negatives cancel, get 9 over 2, 9 over 2 is 4.5. So this really then becomes f of 4.5, because inside here becomes 4.5. Then f of 4.5 means you're going to plug the 4.5 in this now, in the f function. So it becomes a third of 4.5 plus 4. A third of 4.5 is 1.5. 1.5 plus 4 is 5.5. So it becomes 5.5. That is that. This part now says determine what of x if g of x is 5 over 2. If g of x is 5 over 2. So all we have to do is put this g of x function equal 5 over 2 and solve it. So let's write it out. 3x over x plus 1 must be equal to 5 over 2. That's what we're solving. All right, let's copy it down. G of x equals 5 over 2 becomes this. Because this side is g of x equals 5 over 2. So we're going to cross multiply. I'm going to multiply this 2 up here and multiply this denominator up here by the 5. So multiply this 2 up here, we're going to get 6x equal, multiply this up here by the 5, we're going to get 5x plus 5. Because the 5 times of x and 5 times of the 1. Then now, transpose this 5 over here and subtract it to get x equals this 5 right here. So x is equal to 5. That's it. Question done. Question number 10. Number 10
Yes,
as
sir.
well?
Yes, sir. Yes, sir.
Number 10. Number 10. Where are you? Number 10. Number 10. All right. Number 10. This question says we have to calculate that product. So I multiply the rows of the first matrix by the 3 columns of that matrix. The resulting matrix is going to be a, all right, let's look at it. This is a 2 by 2 matrix multiplying a 2 rows, 3 column matrix, 2 by 3. It is possible because the number of columns here, number of rows here equal. The result is going to be of this, a 2 by 3. So the result is going to be a 2 by 3 matrix, a 2 by 3 matrix. So we need a matrix with 2 rows and 3 columns. See, 2 rows and 3 columns. That's where your value is going to be. All right, now multiplying those 2 matrices. So what do we know? The first value here is in the first row, first column. So multiply this first row by this first column. First element times first element, second element times second element. First element times first element, second element times second element. 5 times 2 and 4 times 0. 5 times 2 is 10 and the 4 times 0 is 0. Then this value here now is in the first row, second column. Using this first row with this second column. First element times first element, second element times second element. First element times first element, second element times second element. 5 times 1 and 4 times 3. 5 times 1 is 5. 4 times 3 is 12. And the value out here is in the first row, third column. So multiply this first row by this third column. First element times first element, second element times second element, first element times first element, second element times second element. 5 times negative 4 and 4 times 6. 5 times negative 4 is negative 20. 4 times 6 is 24. Now let's move this bracket. Then the next value now, here. So the second row, first column. So this second row with this first column. First element times first element, second element times second element. First element times first element, second element times second element. Negative 3 times 2 and negative 2 times 0. Negative 3 times 2 is negative 6 and negative 2 times 0 is 0. Then this value here in the middle is the second row, second column. So multiply this second row with the second column. First element times first element, second element times second element. First element times first element, second element times second element. Negative 3 times 1, negative 2 times 3. Negative 3 times 1 is negative 3. Negative 2 times 3 is negative 6. And the last value out here now is in the second row, third column. So to get it, to multiply this second row by this third column. First element times first element, second element times second element. First element times first element, second element times second element. Negative 3 times negative 4, negative 2 times 6. Negative 3 times negative 4 is a positive 12. Negative 2 times 6 is a negative 6, negative 12. Those are your values. You write the final answer, final matrix, which is, this works out to be a 10. This works out to be a 17. This works out to be a 4. This works out to be a negative 6. This works out to be a negative 9. And this works out to be a 0. That is it. Next part says, state why the two matrices in A1 are conformal for multiplication, because the number of columns in the first matrix is equal to the number of rows in the second matrix, them equal to 2. All right, that's the reason why it is conformable. Let's write it out. The number of columns in the first matrix is equal to the number of rows in the second matrix. That's why. Then this one wants to determine the inverse of this matrix. 1 over the determinant times the adjoint. This becomes 1 over the determinant, and the determinant is this product minus this product. Now this product is a negative 10 minus this product is a negative 12. So under here it becomes a 2, right? Because this minus becomes a positive 12. 12 minus 10 is 2. The determinant is a 2. Multiply that by the adjoint of the matrix. Adjoint is obtained by interchanging those 2 on the first diagonal. So negative 2 goes here, 5 goes there. Leave these 2 where they are and change the sign. So this stays where it is and becomes a negative 4. This stays where it is and becomes a positive 3. So then it's a matter of dividing each of these values by the 2. So this divided by the 2 is negative 1. This divided by the 2 is negative 2. This divided by the 2 is 1.5. And this divided by the 2 is 2.5. And that is it. All right. All right. You want this vectors? This one is vectors question as well? Huh? Yeah, man, we're finished now. We're finished now. Online, you want this question as well?
No, sir.
Oh, I'm saying no. All right, you have a question? Huh? Which question, man? Which question? January 2022, number 6. Last question, Meado. Last question. Hey, relax. Relax. Last question. Which question? January what? January 2022. January 2022. Never. A question upon the video. No? There, we could do it. More maths equals better maths. Number 6, you say? This one? So like you want to see it. So. Maybe the man have said that. Alright, let's go. We're going to do it quickly. Question says, relax now. We're going to finish this quick now. Alright, relax now. Hey. Question says, at a track, a cylindrical container is fitted with a pipe as shown in the diagram below is used to serve water to athletes. Cylindrical container has a radius of 12 centimeters and height of 20. That's this thing. And it is completely filled with water and piped. Oh, and the pipe is fitted at the bottom of the spent water into cone-shaped cups. So the cone-shaped cups are radius 3 centimeters and height 8 centimeters. Everything is on the diagram that they have said. All right. It says, calculate the volume of water in the cylindrical container in liters. Write your answer to 2 decimal places. 1 ton cm cube is 1 liter. So that's volume. Pi r squared h, right? That's this thing. So the volume of the cylinder. We can't call this cone. Let's call this L then. Volume of cylinder. Volume of the cylinder. Let's put L for cylinder. It's pi r squared h, right? Pi r squared h. Let me see what's for pi. They tell us what to use for pi. They don't tell what to use for pi. It's a pi in the calculator. All right. So it's pi times 12 squared times 20. That's it, right? The radius is 12 and height is 20. Go that out to the calculator, you get the volume first in cm cube and divide by 1,000 to get liters. All right, so I'm going to use a pi in the calculator times 144, that's a 12 squared times 20. And I said I want it in liters, 2 decimal places. All right, so I'm going to write it here. So first, 9046. And to get it in liter, we divide by 1,000, right? 1, 2, 3. So it's 9.05. And that's the 2 decimal places, right? So it's 9.05 liters. 9.05 liters. I'll move decimal point 3 places left to here. 9.05, 2 decimal places. All right. That is it. Next part now says, water flows from the cylinder along the pipes into the cone-shaped cups at a rate of 7.8 milliliters per second. Now, what you must know is this. That a milliliter and a cm cube is the same, right? It's very important to know that. 1 cm cube is the same as 1 milliliter. Right? So this 7.8 milliliters per second is the same as 7.8 cm cube. 7.8 cm cube per second. Same thing. All right. And they say water flows into that at that rate. It says calculate the time taken to fill one empty cone-shaped cup. Give your answer correct to one to the nearest thing. So what you have to do is calculate the volume of a cone-shaped cup and divide it by this. Okay, flowing at this rate, 7.8 cm³ per second. I want to know how long it takes to fill it. I'm going to calculate the volume when it is full, divide that by the 7.8. That tells you how long it takes to fill it. You understand that? Because the 7.8 is how fast it is filling, right? So the time is going to be equal to the volume of the cone divided by the 7.8. That's the time to fill it, right? And the volume of the cone is 1/3 pi r cubed, pi r squared 8, sorry. It's 1/3 pi, the radius of the cone is 3, and the height is 8. Divided by 7.8. That gives you the time. I think we're going to need the volume of the cone, so let's work this out exactly first. Let's work it out. Let's do it here. Let's do it separate. Let's work it out. I think we're going to need it for the next part. Let's work out what this value is. I think we're going to need it, the volume of the cone. So it is 1/3 times pi times 3 squared is 9 times the height, which is 8. That's 75.4. So this becomes 75.4 cm³ over 7.8. So I divide that now by 7.8, divided by 7.8. So it takes 9.67 seconds. 9.67 seconds to full. That is it. All right. Next one said determine the number of empty cone cups that can be completely filled from the cylinder. So to get that is the total volume of the cylinder divided by the volume of a cone cup. That tells you how many cone cups you can fill, right? That's all. The volume of the cylinder divided by the volume of one cone cup tells you how many cone cups you're gonna get. So that's it. Number of cups equal volume of the cylinder over the volume of the cone cups. The volume of the cylinder up here, we're going to work in 1 unit, cm³, right? So the cm³ we're using is this. All right, 9047.79. 9047.79 over the volume of the cone cup was this. 75.4. That tells you how many cone cups can be completely filled, right? Let's divide them. So the fraction 9047.79 over 75.4. I like 120. I round off on them things, right? I would have maybe put 119, you know, because we don't quite reach 120. But I guess it depends on how much you round off and so. Let's give them a 120 this time. 120. But maybe we should really write 119 because I quite reach 120 yet. That's a mess. But because we've been correcting down, adjusting, maybe we actually get the 120 to work with exact values. Huh? Huh? Go back to the previous question on this. The previous paper. Which paper was that? 2021? No, where is this thing finished? One talk to you know. One talk to no phone leave. One talk to no phone leave. Don't leave. I know watch the video for that one. The video is there. No, serious, the video is there. No, me need to talk to him. Me need to talk to him and people have to leave. I did say 4 o'clock and I did promise not to go home and relax and stuff. Plus me need to go to something. No man, the video is there, man. The video is there. The video is there. Huh? The video is there. All right. Come on, let's do the last one here. Go to the last one here, and then that's it, all right? Go to the last one. We don't know what's coming on the exam paper. Yes, sir. Relax. Now, relax. Now, last one for sure. Last one for sure. Last one for sure. All right, ready. Relax now. Relax. Question said, diagram below shows triangle OAB. OA is vector R, OB is vector S. In addition, E is the midpoint of C. This is the midpoint of CD. And OC is 3/4 of OA right here. It's 3/4 of this whole thing. 3/4. And AD is 2/3 of AB. AD is 2/3 of AB. 2/3 of the whole thing. This is 2/3 of the whole thing. All right. It says that the vector OA is R right here. I don't like where this R is positioned because it can trick me and make me think that this vector is R, right? This is not. It is a whole vector that is R. And down here, so it's just 3/4 of it. And so right here will be a quarter. So I'm going to break up this vector. I don't like how it is set out. Let me break it up from now. So I'm in the exam, I'm doing this and I'm telling you. I'm in the exam room. These are the things I'm doing. I'm wiping this out. I wipe out this. I don't like all that R. It can trick you. Next year, look at the diagram and think that is R. I'm repositioning and putting that this vector is 3/4 of R. That's what I said. OC is 3/4 of OA. The OA is R. See that? So OC is 3/4 of R. So right here is 3/4 R. And then right here now is 1/4 R. And the whole thing was a R, right? So right here is 1/4 R. And then that is the S. And then this is the midpoint. All right, so we have that so far. They tell us that this is 2/3, and that's another 1/3 there. All right, let's answer the questions now. First part wants us to get the vector CD. All right, from C to D. All right, to go from C to D, we're going to need this vector AB. Because what we have to do to go from C to D, that's a good question to do. We have to come up to here first, and then go here. Where here is 2/3 of AB. So we're going to need AB. See that? See that? So let's work out what AB is right here. So since they give us the A and the B here, we can work out the AB. The vector AB is OB minus OA. O times the last minus O times the first. So it's S minus R. So taking this S minus R and putting it right here. Two-thirds of AB. So this is going from C to A and then going 2/3 of AB. All right, ready to put in the values now. The CA is 1/4 R. See that? 1/4 R. And the 2/3 AB is 2/3 of this. And that is AB now. So it's 2/3 of the S minus 2/3 of the R. So it's 2/3 of the S minus 2/3 of the R. Then you consolidate the values. This is the only S term there, so I'm going to write that first. 2/3 S. This now is a quarter plus minus 2/3. Put it as everything over 12. So if we write this as over 12, this quarter is same as 3 over 12, don't it? And this 2/3 is same as 8 over 12. You can see that? Or you can put in the calculator if you want to know. So it becomes 3 minus 8, that's negative 5 over 12. Or if you want, you could put the fractions in the calculator. You put a quarter minus 2/3. You want to get the minus 5 over 12. Let's put on the calculator and show. See there? So you could have done a quarter R minus, this is 2/3 R, 2/3. And the calculator will work it out for you and give you a minus 5 over 12. You see that? It's minus 5 over 12 R. So this is minus 5 over 12 R, as I've said. Minus 5 over 12 R. So that is your first vector, CD. Next part wants OE. This is really a nice question for you, you know. Good question to finish off with. Next question wants O to E. So look at the diagram and we'll just calculate CD, you know. We'll just calculate CD. We go from O to E, we'll have to come up to O here, come up to C here so first, and then go C to E. But the C to E is half of the CD. The C to E is half of the CD. So this calculation will be this now. It's a nice question for you. To be equal to O to C and then C to E. That's how we go from O to C, O to E, right? O to C up here and then C to E. But the CE is just half of the CD that we just calculated. The CE is half of the CD. That's what the CE is, half of CD. So it's going to become OC plus half of CD. Ready now? Half of CD is half of this one, you know. Pay attention now. All right, cool. So the OC is, yeah man, cool, all right. The OC is this vector, 3/4 R. So this is 3/4 R plus half of CD is going to take half of this now. So half of this one is going to be a 1/3 S. And half of this one is going to be 5 over 24 minus 5 over 24 R. Consolidate the values. Put this S value here first. Comes a 1/3 S. And just use calculator to work out these fractions quick and fast. Can know still now, because I won't try the one by 6 to get 18 over 24. 18 minus 5 is 13. So you're going to become 13 over 24. So you're going to add 13 over 24 R. If you're not sure, you can use the calculator and work it out. The R values. So this is 3/4 minus 5 over 24. See it here? 3/4 minus 5 over 24. Look at it. See you get 13 over 24. See it? It's here. 13 over 24. That is it. And that's, you want this part, you don't want the part here. Want a part of two? All right. All right. So this part gives us those points. And first part wants us to write OR as a column vector. Now R is a point -1, 4. R is a point -1, 4. So it's going to have the same values in the column vector. So OR would have the same values, -1, 4. Simple as that, right? One mark for that. Next part wants the modulus of QR. That's the length of the vector QR. You can get from the diagram, you know, QR. Look at QR. From Q to R. From Q to R. From Q to R, if you're counting the squares, every two centimeters is a unit on this horizontally, but vertically every 2 centimeters as well. So this will be 1, 2, 3, 4, 5. So that again. I can mess up. But from Q to R, how many use horizontally, how many use vertical? That's a vector, I know. You can count it off. 1, 2, 3, 4, 5, 6. That's -6. And then go up 1, 2. So QR right now, based on this diagram, is -6, you know. And this question is asking you for the modulus of QR, which is the length of this line, this vector line. The what? This is vector QR, no, this line. You want the length of that line. Pythagoras' theorem. This is 6 and this is 2. The length of this line becomes the square root of 6 squared plus 2 squared. See that? See? Pythagoras' theorem is the modulus. So that is the answer. Square root of 6 squared plus 2 squared. So first, the QR vector based on the diagram is -6, 2. The modulus of QR is the square root of the 6 squared plus the 2 squared. That's 36 and 4, that's 40. Square root of 40 units. All right, square root of 40 units. Oh, question done. All right, good. All right. Online, we're good enough, we're done. So I need to talk to the students on this program now. Online students, wish you good luck. So you can all jump off now. If you want to stay, you can stay. But I'm going to talk to the students on the program.
Thank you, sir.
All right, bye-bye. Bye, everybody. But Kijani and Shakil, well, Atina drum gone. All right, no problem.
Yes, sir. Kijani coming here.
All right, yeah, man. I just want to talk to them a little bit before they go.
Okay, me. Okay, sir.
All right. All right, everybody quiet now, no, please. Everybody quiet. Everybody quiet, please. All right. I'm looking for something. Hold on a second. All right, guys. So we did a lot of work in preparation for tomorrow. All right, and I think we're ready for tomorrow. I can promise you that 100% sure, so nobody in the whole Caribbean not do as much work as this program. I'm sure about that. Right? We have gone through some 28 mock exams, plus questions that we used to do during the year from prior exams. So it's actually more than that. And you have done some 20 of the mock exams on the exam conditions, doing the full paper, practicing on to manage time and all of that. So we're at the stage now where we need to go and put all that we have practiced, all that we have learned, put it to the correct use on the day. It don't make no sense we arm ourselves with all of that and then in discipline cause us to throw all that we have learned out the window. You understand? A lot of the times, there's two things sometimes cause I don't want to use the word failure, but sometimes cause a little bit of problems in the exam room. One is the lack of discipline. One is a lack of discipline. And it's usually the boys who show the lack of discipline. Usually the boys show the lack of discipline in an exam room. And it costs them. When we say lack of discipline, I mean, like, for example, what we're going to do from this evening, which is to go to your bed and sleep and get 8 hours sleep. Because you need to be very rested in the exam. You don't want to go into the exam room with not tired brains. You really don't need to do any more maths between now and tomorrow. Now. No more at all. You know. We have done enough. We have done more than enough. Could have done the exam from last week, week before last. We just have to do the exam on the date that they set it. You get me? But we've been prepared from long before. We just dot the I's and cross the T's. You get me? So you don't need to go tonight. And if it's one night, you go and go to your bed early and sleep, and just no bother with the games, no bother with the TikTok, no bother with the Instagram, no bother with the YouTube. Just no bother with them things. Right? Tonight is the night for you to go and get that 8 hours or more sleep so that your brain will be fully rested. Follow the instructions to the T. You don't need to study nothing else. Oftentimes you go and say, boy, I'm going to try to get this, I'm going to try to get that. You have to have confidence that the information is there in your head. If you're rested, it will come out on the exam paper. It will come out even easier if you are rested. Because when you're rested, you're able to think more clearly. You're able to focus. You're able to concentrate. I can tell you now, there's a big difference between the Sunday students and the Monday students. Because the Sunday classes are in the morning on a Sunday. If you come here on a Wednesday afternoon, you can see people more agitated, and people more relaxed in the early morning. Some people relax all the time, but generally speaking, the same person who kind of edgy in the evening is relaxed in the morning. You get me? And that's because you have gone through a whole day of work and at school, and you're kind of tired and you get agitated. You're not rested. When you're rested, you tend to be more calm, you think more clearly, and so on. So you all need to go and just sleep tonight. That's the first thing. The girls now, what causes the girls in the exam a lot of the times is that they panic and they get nervous. You understand? That used to be what get the girls in the past. I find that in recent times, the girls kind of have got more confident in recent times. It's a change in time. Because when I used to go to school, no girl couldn't get higher than me. In fact, girls never used to get higher than the boys when I used to go to school. But the fact of the matter is that the reverse is true. The girls doing better than the boys, generally speaking, no. And so it must mean that they're also now able to relax in exams. But the point is, don't let nervousness get you in the exam room tomorrow. You understand me? I know the girls will be disciplined because they generally are, right? And nervousness is what usually get them in the exam room. So listen, you're not gonna panic for any reason in the exam room. Listen to me good enough. You're not gonna panic for any reason at all in the exam room. What usually causes people to panic in the exam room is when they see a question and them not see how them go and do it. Sometimes people go in an exam and they say, okay, matrices are my topic, for example, or bearings or whatever. One, you might don't see no bearings, or you might don't see a topic where you're going there for. Or you might see the topic and it just come different, and you look away at you and you not see it. And then you panic and you just get edgy. And you forget about the time management. You have to remember the time management plan. You have to stick to the time management plan. Right? Don't panic no matter what. I want you all to remember the statement. I wrote it in the little document that I sent to you the other day. I want you all to remember it because it is true. I'm not telling you nothing. That is not true. I'm telling you this because it is true. Any question you see on the exam paper that looks strange to you, that look like it ought to give you a problem, remember that every other student in this whole Caribbean dying from it. If it give you a problem, it will give everybody else problem. So don't think about a word about it. You get me? If it give you a problem, if it give you in this class problems, you don't need to worry about it because it therefore means that it is giving everybody else far more problem that it's giving you. Why? Because of the level and extent of your exposure to questions. There's no type of question that CXC ever said before that you are not exposed to. You might not remember it fully, but it's somewhere in your head that we have gone through all of them. So if it looks strange to you, it's totally vague to everybody else. If it's hard for you, it's mountainous for everybody else. If it's difficult for you, it is far, 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 far more difficult for everybody else. So you just do what you can on it and you move on. Give it the amount of time that you allot for each question. Do what you can do on it. Write what you know. And you move on to the next question. You have to stick to the time management plan no matter what. The first thing I normally ask my students after exam, the very first thing I normally ask a student after exam is what? Did you complete or attempt all 10 questions? Did you do work on 10 questions? Worst thing a student can tell me is that the time up and they never reached question 10. I never reached question 9. That's the worst thing ever a student can tell me. You must absolutely not, listen now, listen. Discipline starts with listening as well. You can absolutely not come out of the exam room and not attempt every question. I have given you the framework to ensure that you attempt every question. You have to stick and work with that structure, that plan. Give each question that amount of time and you move on. It don't make no sense to spend 10 minutes chasing down 2 marks when there are 12 marks and 10 marks that you can get for the same 10 minutes on the next question, another question. You get me? Now, we have practiced to just go from question 1, we want to question 10. I'm not going to tell you that you have to stick to that method. All right? Oftentimes, you look at a question and you do the parts of it that you know for sure. But what the risk of doing that is that sometimes you forget that you leave out a part of a question if you keep leaving out. You get what I say? So you run the risk of that happening to you. But we have practiced so much that you shouldn't have the need to believe in out a lot of stuff. You get what I say? You shouldn't have the need to believe in out a lot of stuff. People ask me all the time about writing with pen versus writing with pencil. Personally, I recommend writing with pencil that is dark enough to be seen. Why? If you notice, they don't give a lot of space. And if you write with pen, you can't erase something. Sometimes you make a mistake and you want to erase. You can't erase pen, yes? They want what? No. That is not a true. Over the years, I tell my students to write with pencil and then write with pencil. The reason I'm saying the pencil, just want it to be dark enough. Your paper is going to be scanned and emailed to the markers. That's what the marks you see. Them scan the paper and then email it and then put it on a site and the teachers go on the site and mark it. Teachers stay them yard and mark the paper there. It's not like in the past where they used to go and take the actual paper and look at it. You just want to ensure that if your eyes can see what you write, when they scan it, it will be able to be seen as well. So you want to make sure that whatever you're writing with is dark enough. The risk with the pen is that you can't erase and your work becomes messy. Remember this as well. Anything you cross out, they're not going to even look at it even if it is correct. It is better to have 2 answers on the paper with different and leave them there. Once the correct answer is there, you have to give your marks. Yes, but if you cross out the right thing, I have a wrong thing beside it. Nobody feels some have a compassion and give the mark for the wrong thing where you cross out. Once you cross it out, that's it. Then now I look at it even if it is correct. Crossing it out means that you're done, you're not bother with it. But if you leave it, so somebody have a solution and you're not sure. If this is the right way or that is the right way. Just for argument, that shouldn't be happening, you know. But let's say you do that way, you get answer 10. And do that way, you get answer 15. Better you leave it to them. Right? Because if the right first answers on the paper, they have to give it the benefit of the doubt and give the marks what is correct on the paper. They cannot, but if you cross out one of them and you cross out the right one and leave the wrong one on the paper, they not give the mark because you cross it. They're not looking at anything that you have crossed out. They're not even looking at it, even if it is correct. You get what I say? Yeah, just still have a minute. Just still have 1 minute. Come in a minute. Yeah, close the door. You get me? They're not even gonna look at it. You get me? But we shouldn't be in that pickle still. We're just doing the work and just getting them right. You get me? So guys, I told you as well, they're not doing any more maths from tonight. I'm serious about that. Very serious. The first question you must do between now and the exam is the first question on the exam paper. You can't have nobody come now and be asking you to be showing them how to do stuff that is exercising your brain. You need to be resting your brain. Your brain can get tired too, you know, like any other part of your body, you know. I don't want to go in the exam with a tired brain. You need to rest your brain now between now and the exam. Total rest. Rest your brain. Sleep. Tomorrow morning, in fact, from tonight, package everything that you need for the exam room. Timetable, the calculator, put the calculator in degrees mode from now. Make sure the battery all right. Sharpen your pencil, your pen, everything that you must have, your eraser, your geometry set, check your geometry set, tighten your geometry set, sharpen the geometry set pencil if you have to use it. Do all those preparations from tonight. Iron your clothes, for that you do. Just get everything ready from tonight. You don't want any eventualities in the morning. You need to get to the exam room early. If you get to the exam room late, you're gonna end up in panic state. You're gonna start panic. And you don't want that. You want to do the exam relax from the first minute. You get me? So get to the exam room early, no later than 30 minutes before. Some centers big and you have to search, and everybody in the school doing maths, you have to search for your exam room. So as you reach, find where your exam room is. Your exam room usually is with your the center number. So your center number is what I'm talking, especially the fourth formers who don't do the exam yet. The center number will basically, your center number is what they use to identify your room that you're in. So you find the room, search for the room, identify where the room is. So that when the exam starts, I see exam start when people walk up and look for them room, they don't know where the room is. That don't make no sense. Yeah? Yo, you guys come in here, I don't know which room they're gonna put you together. When they come, we'll listen. I'll be here in the morning as well. Right? But you come, but your first aim is to find where your room is. You get me? Listen now, tomorrow morning, if you know something normally make you drowsy, don't eat it tomorrow. Things will make you drowsy, nobody eat it tomorrow. You want to eat a nice solid breakfast, you want to feel hungry in the exam room, no time at all. It's an early morning exam, you don't have to go too heavy. You don't want to go eat and make you get drowsy. So choose what you eat wisely in the morning. You get me? Right? Next thing, make sure you use the toilet before you leave the yard now. Everything important, right? Come remember now, it's the whole school coming here, you know. It's the whole school going at the center. Everybody do maths in the schools. So when you go there for some subjects, not everybody doing, but everybody do maths, just like everybody do English. So English and maths are usually the biggest days in terms of attendance, biggest days at an exam center. So you don't want to have to be depending to find anything at the school. So for example, don't say me I go to school, go eat breakfast at the canteen. The canteen is full. So eat the breakfast at your yard. If you normally go to school, go eat breakfast at the canteen, nobody do it tomorrow. Because the canteen is full, because the whole school is there at the canteen. You get what I say? So just eat the breakfast at your yard and you reach school early. If you have the tendency to feel a little bit nervous, you can carry a little bit of honey with you. But you can't drink too much of the omni either, you know, because it will make you get drowsy too and sleep. You don't want to calm it down to a point where you want to sleep. Just want to calm it down to a point where you're not nervous. So usually just 1 little teaspoon of honey, calm it down. If you don't have honey, anything sweet, but you can't drink too much sugar because sugar make you drowsy too. Just like a sweetness for you, like a, just something a little bit sweet for you, like a pep. And remove the nervousness. Huh? Let me put in the tea. No, me I say, all right. Me I say, you know, say too much sugar gonna make you feel thing. You better go and look at sugar something tomorrow. Right? So I'm saying, even though I'm saying something like a bit sweet to calm you down, don't make it be no big long drink, no sugar with big long sugar with drink. You get what I say? No big long sugar with drink. Right? Look at honey at the right thing. It's a small amount of honey, 1 teaspoon. Calm yourself down. You get what I say? And remember, guys, remember, if all else fails, right? I don't know if you are praying people. If all else fails and you feel things, just say a little word of prayer now. Right? Just say a little word of prayer to yourself and whatever, say a little prayer and ask for help in the exam room, for calmness, and so on. Now listen now. When you're in the exam room, a lot of persons in there gonna be agitated. It happens in the exam room. People be knocking the desk, shaking the table. I say, what is man? What kind of question this? We never see this yet. All them things there. Do not be thrown off by those things. You don't know the preparation that those persons had. You understand me? Sometimes you go in the exam room and you know a man named John Tam, I know him bright like hell normally. And in the exam room, I say, what is man doing? And you might get nervous. And I say, oh, John Tam, I said this. You can't feed off other people because you don't know their preparation. You understand me? You only know your preparation. Right? And you know, listen now, hey, hey. And you know for a fact that you are well prepared for this exam. You are well prepared for this exam. So you don't have anything at all to worry about. Just go in there and follow the time management plan. Execute. When the exam done, listen now. Last thing I will tell you now. When the exam done, and come out of the exam room, and send me a text message with the word soft in it. And that's what the exam is going to be. Soft. With a capital T. Alright? So see you guys tomorrow. I have people want to work on. Alright? Alright. Bye everybody. Alright, students online, that is it. Good luck in the exam tomorrow. Alright, Kijani. Alright, Shaquille. Other students, good luck tomorrow. You can send me a message and let me know it go. Alright, bye. We're gonna do some work for the paper one. Alright, I'm gonna end it now. Bye everybody. Somebody's asking for another name of the displacement vector. It's a displacement vector. The position vector is the vector from the origin to the point. That's a position vector. Displacement vector is usually the term used for the vector between 2 points other than the origin. All right, that's it. It's not complicated. It's not complicated. All right, I'm going to end the session now, though. All right, bye, everybody. Good luck tomorrow.